There we go. I finally unmuted my mic. There we go. So yes, we're finally back to C++, and in this case, string math. So if you go watch the VOD that we have last time, we finally implemented addition, subtraction, and subtraction saved. Now, according to the roadmap, now we have to figure it out multiplication and division and modulation in this case. So, let's go. So first thing first, we just go string and then whoop, nope, multiplication. For now, we don't care like any like how many decimal points we want, we just do the raw stuff whatsoever. And wait this. There we go. Go. So now we just go here and then just figure it out how this should work. So assume that we have the following situation, like A, B, C, D, E, and then over here we have X, Y, Z. So I would say at this point we definitely need addition, because in some sense multiplication is actually repeated addition. So what we can do is assume that we have the following. And then we just do multiplication sign. So at this point we can just do something like and then I believe some of you definitely gonna say something like, hey, there are actually more efficient ways or something like that. Well, I'm just going to do the straightforward way for now. Go. Oh, there we go. There we go. Perfect. So what I would say is, for every digits we have on the shorter side, or on the second thing, we just keep on doing multiplication, but also at the same time, we're just going to like smacking zeros at the end of it. Oh. There we go. Like over here, we're just gonna smack zeros at the end for every answers we have. So, and then afterwards, we are just going to like output a whole bunch of like strings, and then soon afterwards, we will sum up all of these strings by using addition. Okay. So let's see. First thing first, we definitely need to do is to like strip off all the decimal points, because technically speaking, once we strip it off, afterwards we can just like put it back in afterwards, but we have to store it somewhere else. So in this case, we'll just do string plate A is in A, string plate B is in B. Oh boy, I'm loving these music so far. And guess what? If you like the music as well, go take a look at on our team's SoundCloud. Alrighty. I wonder if I just do for and then just go string and then go manip. Okay, I remember there is a way to like remove some specific characters though. Let's see where it is. Substring replace. Oh, that might do the job. Okay, let's do that. First, it's the input, which is in A. Okay. Target, which is just a single dot. Change it with nothing. Alright, do the same thing. Manip. Substring replace. In A. No, this time in B. Don't want the little dot. Replace it with nothing. There we go. Remove the decimal point. Okay. So now we can do for int starting from 0 smaller than plate B length. Whoops. Okay, then do the following. So basically you would say current number index, which is the place that we will be looking at. So basically it would be something like plate B dot length minus I. So for example, like right now our plate B has now 3 characters, so this one is 3. 3 minus 0 is 3, but we want to look at position number 2, so we will say minus 1. And then for the second iteration, I becomes 1, so 3 minus 1, that's 2. 2 minus 1, that's 1. That's position 1. Next thing, yeah. And then do the same thing again and again and again. Okay, cool. Also, over here I would like to have another vector of string. I'm going to call this thing plate. What should I call them? Plate sub. Okay. So now over here I can start naming stuff. Like for example, this is actually plate A. This is plate B. And just in case, let me check my playlist. Is it all over? Nope. Okay, there we go. Good. This will be plate. Let's call this thing S. Okay. And then 0. Plate S. Whoop. 1. There we go. Plate S. 2. And then this one will be plate R. Okay, so we have that. Plate S for now, it's empty. And then now we're just gonna do multiplication whatsoever. So let's do some stuff. So let's go int. We can do arith A. For now it's 0. Int arith B, which is the arithmetic value that we have at the current iteration. Over here we can say int arith. Over here I can say O is the outcome. From plate A, from plate B, the output. Over here I can also say arith, and then go C. And then we can go with this, the carry. Now, is it possible that the carry can be like 2 digits or something? Let's take an example. So we're just gonna take an example in base 10. After all, 10 is actually just an arbitrary number that human likes very much. Take 9 multiplied by 9. We have 81. Meaning we have an output of 1 and a carry of 8. And we're already good. As you can see, the carry is just 1 digit and it's safe. Don't trust me? Okay, f multiplied by f. In this case, base 16 or something. 15 times 15. Oh boy. 15 times 15. Let's see, what do we have? 75 plus something. Plus 150, if I'm correct. You know what? Okay, I'm gonna put it this way. 15 times 15. Now I'm thinking in terms of degrees. So 15 is 5 times 3. 15 is also 3 times 5. 5 by 5. 925. 925. 8 plus 1. So that is 225. 225 in base 16. Let's see. 225. 128 plus something. You know, since we have this, why not? Oh. Ooh. 225. 128. There we go. Did I forgot to save it? Yes, I forgot to save that. That's why it ran the last iteration of what we had before. FD. So as you can see, Oh wait, I was wrong. Oh lord. Let me fix it real quick. There we go. Oh. Save it. Run it. There we go. 97. So in this case, 97. 97 is 96 plus 1. Now, okay, 128. 128. 96 is actually 16 multiplied by 6. I'm able to recognize that. 128 plus 4 and 2. So 4 times 16 is 64 plus another 32 plus a 1. So in binary it would have been 1 until 32. That is a 32, 64, and a 128. Is it? 1, 2, 4, 8, 16, oh. 16, 32, 64, 128. Yep. So in binary we have this, and this translates to C plus 1, that's D, and then 1. So FF is actually D1. I mean F times F is D1. So as you can see, we are safe in this case. Like the carry is always going to be 1 digit. As we can see, we both tried for base 10 and for base 16. So we're safe, so that's good. Alright, and I think we are good to go. And then in this case, I would say we're going to use a while loop. Could be dangerous, we'll see. Over here I'm just going to say int j, just like how we use int I in our for loop. So over here I'm just going to say when j is, hold up a second, no. I'm going to say it's plate A dot length minus 1, pointing at plate A. And then if wait, now I have a better idea. Plate B length minus 1, as long as I is smaller or equal to 0, and every time when we're successful, minus minus. Yeah, that's one way to do it. Yeah, I like that. I like that. Okay, cool. I like that. This means that now typically saying this means we can just use a double for loop in this case. So let's do int of j, starting with plate A dot length minus 1. So we know we're starting at the last character, and as long as J is still within bounds, then we're good. And every time when we do that, J will go down. So first thing first, we need to know the arithmetic value for arith A. So, okay, for vector, find object position from our character set, find our target, which is currently plate A at J in this case. And we're gonna search it starting from the left. And then this will be arith A. Over here at this iteration, we can do the similar stuff. It's just we need to get the value for B. Whoop. There we go. Arith B from plate B. Position I. So now basically we have arith A and arith B. So in this case we can just say arith O is going to be arith A multiplied by arith B. In this case, we're gonna cheat a little bit and then just use a built-in multiplication, otherwise we're gonna die. And once we have that, we just need to like make sure that arith O, let's say if arith O is a little bit too big, meaning we have carry, then we need to carry it. So in this case, arith C is arith O divided by character set dot size. And then also arith O will be arith O, but this time mod character set size. So we have that. Oh, I almost forgot. Arith C. At this point, arith C is from the previous carry. So I'm just going to say here, arith C is from the previous carry. And then afterwards, when everything is done, it's just gonna refresh it. And then when the whole string is done, it is possible. Oh wait, I almost forgot. Every time when we figure it out what is arith O, okay, we're going to call this string temp s, which is corresponding to these over here. So everything over here is a temp s string, and then afterwards we will push them into the vector. So do we have that? Yep, plate s. So over here we're going to say arith, no, temp s is equal to character set arif o plus temp s. So we have that, and then afterwards it's just gonna do that again and again and again, and then when the whole thing is done, meaning there are leftover carries, then we are going to say temp s we just do this. Excuse me. Okay. Leftover carries. And then when that is done, we can say plate s dot pushback. Over here we have temp s. So every time it's gonna do that, and then every time it's just gonna refresh. And I think it should work pretty well. You know what? Afterwards, I'm just going to like force print what is the oh wait, I almost forgot. We also need the extra zeros at the end. So excuse me. Get the substring ready. And then over here, I'm just going to say for int I again or whatsoever. Or wait, you know what? Plate B. Oh, okay. Okay. For int z, because over here we're just going to like padding it with zeros. Wait. I think we have that. String manip padding. Haha. There we go. In string. Okay, I don't know what we have here first. Oh wait, we can just actually just there we go. Pad the zeros. So over here it's actually temp s. That's a string that we want to tap. And then for the fill, it's just 0. Wait, I'm going to say for string char to character, so it's actually convert char to string, character set 0th, and then we're good. Size. Ooh. Wait, that's not a good idea. No. Not a good idea. No. Yeah, you know what? Let's just pad it before. So let's go with for int z starting with 0. As long as z is smaller than the current iteration, which is I believe. So when I is ooh, wait, this is different now. Okay, let's see. Let's do plate B length, in this case minus I, and then when I is at the perfect length of it, let's go with like just -1 minus I. So plate of length -1. So let's just say our plate B has a length of 4, and then when I is 3, at this point we don't want any 0, so 4 minus 1 minus 3, perfect. Now when I is 2, 4 minus 1 minus 2, so that's 1, we need 1 0 of it. And then when I becomes 0, yeah, yep, sounds about correct. Okay, cool. And every time z plus plus, z starting from 0 as long as z is not z plus plus, we can say temp as is temp as plus character set 0. Adding the 0. There we go. RFC is from the previous carry. Yep. Leftover carries whatsoever. Okay, afterwards I'm just going to do a force print. For dot, let's do a cout. Force print vector. In this case, it's going to be plate S. Oh yeah, we should have way many stuff. Vector name. Let's call that plate S. Item left side. Nothing. Separate. Let's use a comma. Or in this case a plus sign, because soon afterwards we know we need to plus them together. Right side has nothing. Padding length. I don't think we need one. Align direction. Fine, let's go with center or whatever. Padding string. For safety, let's go with a space. Okay, so I don't know will this thing work, but let's just do very simple math. So in this case, we just go back over here, and then for simplicity we're just gonna do very simple math over here. So whoop, and then let's go multiplication, string. Let's do 1 2 3 4 5, and then let's go 6 7 8, and let's see what will it give us. I almost forgot. At this point, cout won't work, is it? Alright, for now, they're just gonna say, let's return an empty string. I don't know. Or they'll just say, okay, wait, we're not done yet. Okay? So, let's see what will happen. I don't expect it to, like, work exactly. Also, number is pos is neg. Oh. Yeah, although we have taken care that it will return a string, it's just the compiler don't like that thing, so let's just say return a nothing string. What else? Subtraction safe. Oh. Return. Okay. If error. Ah, there we go. Let's compile it. There we go. So it might return something like, I mean print something like really funny. Just see. Uh-oh, it gets into a while loop. I killed it. There we go. Multiplication. Like so far there are no like while loop or something. All of them are for loop. Zero. Z is smaller than that. Z plus plus. J starting with that as long as J is bigger than that. Okay, time to do some couts, I would say. Let's go cout. There we go. And over here, I'm going to use the flag emoji. Control C. This is 2. This is 3. This is I. This is Z. And this is J. And then 4 is over here. Here we go. Let's see where will it get stuck. Now the weird stuff is eventually it ends. However, okay, I'm thinking maybe the -1 is doing something funny. Alright, let's take a look. Force print vector. Oh wait, no, it's in the cout class. Okay, there we go. That's the padding length. Okay, so it has something to do with padding. Okay, which is in the string class. And that is manip. Padding. There we go. When in size. Okay, while in size. But the size over here is a -1, and -1 is never -1 is never bigger than 0, so you should just get out. Wait, 1, 2, 3, 4. How many does this one has? 1, 2, 3, 4. Oh, okay. What if we just go with just that? Huh. Does it print anything at all? Force print vector. Huh. Vector name, item left side, separate right side. Oh, this gives us a string. Oh. So instead, we need to say see out this thing. Yep. I'm out safe. Also, I'm going to quickly make note over here. Padding. Padding length cannot be negative. I'm just going to say a warning about that. So at this point, let's just see. We do not need the flags anymore. We don't need this. Don't need this. And we do not need this. Do not need this. And then we do not need this. And we don't say this. And then how about we just go cut this thing, paste it over here. We just want to see what it gives us. So now we can just like recompile and see what it gives us. There we go. Okay, let's see if this is correct. Okay, looking from the zeros, it looks pretty good. I guess. Oh, I almost forgot. I'm going to say Arift O is going to be 0 as well. Arift C is going to be 0 as well. Hopefully that helps. Otherwise, that's a little bit odd. Huh. Same result. Well, let's see what it says. I'm going to pull out my calculator on my phone just to see if this is correct. Cancel. There we go. So in this case, we have tested 1, 2, 3, 4, 5. Multiply by the first one is 8. So the first chunk is correct, and then 7, 8, 6, 4, 1, 5 with a single 0. Finally, with a 6, we have a 7, 4, 0, 70 with 2 zeros. Ah, okay. So at least we are pretty good. Like, at least we get all the substrings correct, so that's good. Now we just have to like add them all up. So that's, yeah, not exactly a problem. I hope. Now let's see. Now, instead of having a whole list, I'm thinking like every time when we came up with the S string, we just add it to our result. Oh, okay, I like that. So we don't need a whole vector to do that. Temp S. So instead of temp S, let's have something called plate R and plate S. Yeah, we can do that. No, the only problem becomes, oh, yep, there goes plate S. Okay, let's do this. Let's go with string plate S. For now, it's nothing. We'll take care of it. So this one's gone. Also, at the same time, let's go with plate R. So there we have that. Now, temp S. Let's say, yeah, this will be our plate S. Get the substring ready, excuse me. Okay, plate S is plate S with a whole bunch of zeros. And then every time when we are good, we just say, okay, our plate S will get updated with these new values. And then the plate S will also take care with the carryovers. And then push back. Now I'm just going to say plate R is going to be addition between plate R and plate S. And then it just keeps on doing that. And then finally give us plate R. Yeah. So let's do a quick compile and see if it works. So there we go. There we have our first try, which is 8369910. I don't know, will this thing works? Time to punch it on my calculator. And from the looks of it, there we go. It looks pretty good. There we go! Yay! We have implemented simple integer multiplication. There we have it. So now the next problem becomes, what if we have decimals? So the first thing first, we need to like take care of the decimal point, and then once we've figured out what is plate R, then we should be good. Over here, I'm just going to say, okay. Over here, I'm just going to say, start doing the times table. Okay, so over here, I'm just going to say this is actually part 1. And then over here is part 2. Let's see, what else? Over here, also, I'm just going to say, before we return... Okay. Now, plate R has the sub answer, but not yet. Over here, I'm going to say, part 3. Put the decimal point back in. So over here, we just need to like figure it out. What is the fraction length of it? Oh wait, I forgot. We also need to clean it. You know what? I'm just going to like copy and paste this part. And instead of part, I'm going to call it step. Remove extra zeros. Remove extra zeros, so that would be also, I'm just going to say prepare variables. I'm just going to say that. String. So we have plate A, plate B, plate S, and plate R. Also, plate A is going to be in A, in B. Remove the extra zeros, so... Oh, boop, boop. There we go. Where's it? Number clean zeros. There we go. Number clean zeros. Plate A. There we go. Plate B. Oh. There we go. Number clean the zeros. Plate B. Alright. So now we have those two correct. Now, step 2. Remove the decimal point. Over here I'm just going to say whoop. There we go. Here we go. Now at this point we're just going to check if anything is empty at all. So over here it will be step 3. Check if any of the input strings are empty or just zeros. So let's just hit save. I just want to like see. Let's say it's clean zeros. Okay. I wonder how good our clean zero is. Let me give it a quick test. So for now, just do this. And then over here we can just do small wall. Number clean zeros. Let's see what it gives us. Oh, it just gives us a good 0 right there. What about this? Or, you know what? There we go. Yep. All of them did a pretty good job giving us zeros. Like, yep. Like, I have to say, these looks pretty naughty. And we got them covered. So that's good. So if we come back over here. First, we prepare the variables, remove the extra zeros, and then remove the decimal point. So assume that one of the given things are those nasty strings that we have before. First, clean the zeros. Whatever we have is just 0. Like at this point, we don't even have a decimal point. So in this case, we just need to check for 0. So if plate A is okay, for string convert char to string character set. Oh, character set 0, or if any one of them is just 0, right? Just say 0, because according to multiplication, we know if any one of them is a 0, you just get 0. Well, I hope C++ is clever enough in order to do... Well, it's not clever enough in order to do... conversion, I would say. There we go. And then this one over here would be step 4. And then this will be step 5. Put the decimal point back in. So over here we are going to do number. And then we can see, oh wait, whoa. Okay, over here I'm just going to say int, we'll just say true fract length of A. For now it's 0. And then let's do int true fract length B. For now, it's also 0. So once we remove the extra zeros, now we can actually start counting what's the fract length. So now we can say number get in length. Oh, what's the fract length? There we go. In this case, plate A. Oh, does it even say anything? What does it want? Include tailing zeros. I've forgotten that I have accounted for that. So in this case, this one over here will be number fract length. In this case, this one will be in A. Including tailing zeros, we will say no. Also number fract length in this time B. And then over here, this one should be false. Hey. So there we have that. Also multiplication. Okay. Let's see. Also, I'm also like thinking we also need addition safe. And then over here I'm just going to say it will return, wait. And then over here we're just gonna say, okay, account for negative inputs. Okay, so soon afterwards we'll take a look at that. For now, we'll focus on this. Put the decimal point back in. So in this case, let's just go with true fractal length A and true fract length B. This will give us the total fract length. So in this case, I'm just going to say for there we go. For int starting from I, starting from 0, as long as I is smaller than this, I plus plus, no, I plus plus, there we go. And then we will go, let's see. Plate R. Okay, let's just say plate P. I don't know. And then now we'll say this will be the final answer, and then we will return plate P. So let's take a look at that. Or, okay, is there a way to like collapse stuff? No? Sad. Okay, fair. So over here we can say ooh, what do we really want though? Okay, we're just gonna say plate P is plate P, but before it we'll just plus plate R dot add something. And then over here, I'm just gonna say it's plate R dot length, and then -1 minus I. So for example, what I'm going to do here is plate R. So just say if plate R is this whatever we have, then over here this one is length -1. This one is length -2, length -3, length -4, length -5, and all that stuff. So this is what we get when I is 0, when I is 1, when I is 2, when I is 3, when I is 4, and so on. So this means that when it hits the supposed decimal point, then we will stop, and then we will put in the decimal point, and then we will continue. So Okay. So I'm going to say if I is equal to plate r dot length minus whatever this is. No. Oop. Copy this thing, paste it over here. What? Whatever it does, it will just say time to add the decimal point. Whoop. Add the decimal point, and I continue. And then at this point, oh boy, so at this point I'm thinking from like counting from the right hand side. So this means that this will be plate r dot length minus 1, starting from there, and as long as I is bigger than or equal to 0, it will do the following, and every time when we're successful, minus minus. And if I happens to be the supposed position of our decimal point, we will put it there. And then afterwards, just there we go. And then afterwards, we will have that. And then also, to make things a little bit cleaner, we will just say number clean the zeros. We don't want like any funky stupid stuff. Okay, so if we come back here, this one's gone. This one's gone. So let's just see if this thing still works or not. So we still have this, which is the correct answer, I suppose. But it did not clean the 0 at the end. So that's pretty odd. Let's see how it works. Find character dot if in part plate. Oh, okay. Huh. What situation does import has? Okay. Okay, I'm just going to say there is no dot meaning we only have an int part. There we go. So we have that. Hmm. Um. OV, I'm going to say fract part will be this. Now, technically speaking, okay, let's make another version of this. So, whoop. In GitHub terms, we're going to make a branch for this thing and see if it works. If no, at least we can fall back. Whoop. Cleaning zeros 2. So we'll just pull this thing. Huh. Okay, I'm going to cut this thing and then put them right here. And then now, whoop, there we go. So now, and then words deal with the in part, deal with the frac part. Okay. Now let's see. If we were to use the second version of it, what will happen? So, whoop, whoop. There we go. Let's hit save. And then let's see if anything funny will show up. So let's hit save as well. Hit compile. And there we go. Looks pretty good. Okay. So for now, let's not deal with that. I just want to see if the cleaning 0 is really working. Small wall dot number clean zeros 2. We're just going to have a whole bunch of stuff. And then let's start with an empty string. Server with a single 0, triple 0, and then 0 dot. And then some of those. One, two, three, 4, 5, 6. There we go. Over here. Oh. I don't know. Let's see. Let's hit save. And then let's see what will it give us. Boop. So let's see. Empty string. We have 0. Okay. 1, 2, 3, 4, 5, 6, 7, 8. Meaning the first 8 are actually all zeros. And technically speaking, yeah, correct. All of them should be zeros. Next, we have 1, 2, 3. Yeah, good. 0.123. Good. 123.456. Good. 123.456. Good. And then with the 6 digits, yes, good. 0. That. Yep. Yep. Looks pretty good. Yeah. Okay. So this means that. All right. There we go. So now this means that we can actually throw away this one. And then this thing can be the new one. Hit save. And then down over here, we definitely have some ANGI codes. There we go. Remove that. Remove that. What else? Yep, there we go. Hit save. And then if we come back over here, all of that will be gone. Back to testing this. Also at the same time, we're just gonna test some decimal points and stuff. So assume that we have this, or that, or this, or that, or this. Or I'm just gonna be naughty and I just give you that. And then afterwards, I'm just going to say cout and line. Whoop. Whoop. And then there we go. This one will have that. There we go. Let's see, what will it give me? I'm expecting a whole bunch of like weird answers, because the arithmetic itself, well, yeah, fine, whatever. It's not weird. It's just, it does not look that beautiful or whatsoever. Oh, we'll see. Whoop. There we go. So at this point, we just have a whole bunch of stuff. And from the looks of the numbers, yeah, it looks pretty good. Wait a second. The first two should have... Huh. One, two, three. This one should have 5. Let's see what's the problem. Okay, that's fine. Let's just assume that we have A as and then we have this. Then we're going to expect this thing to have whatever it is, but we will have 1, 2, 3, 4, 5, 1, 2, 3. And then we're going to assume that it has this. Okay. Okay, let's take a look. I'm going to use the letter V as my little pointer. Huh. Or wait. Yeah, there we go. Over here, that is when I equals to the length of plate R. When it reaches over here, oh, it should have been when it reaches over here, so we're missing a -1. Let's hit save, and then let's compile it. So now from the looks of it, this looks way better now. Like this one over here, okay, cool. Divided by 10, that is missing. Divided by another one, now we gone there. So if we take a look at, let's just say this one, okay? 1, 2, 3, 4, 5, 6. Oh crap. Got to be kidding. Or wait, no. 1, 2, 3, 4, 5, 6. Oh yeah, 1 0 is missing because according to this answer over here, there should be a 0 at the end, but because that is a trailing 0, so it removes it. Okay. So, yeah. So just to test if this is correct, I can just say 0.001 and 0.000001 whatsoever, right? Let's see what it says. Huh. That should not happen. Let's see. Do we have like any like cleaning zeros somewhere in between? Because that should not happen. Fract length. Clean zeros. At this point, we only remove the int part of it, or whatsoever. Alright, let's take a look. So over here, let's just go cout, and then we just go let's see what does it says. Whoop. Yeah. It looks good. Remove decimal point. If any of the strings are empty, just zeros. Okay. Do the times table. Okay, over here I'm just going to say got R. And see what this is. Got R1. Huh. Okay, also I will be needing fract A, meaning the fractal length of A. Let's take a look at this. Three and 6. Yeah. Yeah, that's good. Oh, this explains it. It never hit when I is supposed to be that. Oh, shucks. Huh. Ooh, boy. Good question. How do we even put the decimal point? Okay, so over here we have two situations. Okay, we're gonna document it right here. So we'll say here we have two situations. Either plate R is longer than true fract length A plus true fract length B, or else what if they're equal? Yeah. There we go. Either this And then this part over here, oh boy, that's the hard part. Huh. So over here we can actually just do an if statement. So if we can do plate r dot length if it's the classical one. There we go. Oh, it should be plus. Yep, there we go. And then just simply just do this. Alright. So we have that. Or else, if it's too short. Else if you just copy and paste this whole stuff. Whee. Cut it. Go to the left. Paste it. So assume that now we have this, which is actually the situation we have right now. So what we're gonna do is, oh boy, we need a while loop. So we can just say like right now our R is like, it's actually clean because we're actually using addition over here. That's why it is clean. So we can say like at this point we're just gonna say plate P is plate R whatsoever, copy it from it, and then afterwards we're just gonna say while plate P length is smaller than this thing, we're just gonna keep on padding zeros to it. So plate P will become character set 0 plus plate P. And then, oh, whoop, there we go. And then whenever you're done, we're gonna say plate P is character set 0 plus dot plus plate P. You know, just a perfect 0 point something at the beginning, and then afterwards should be done. So let's hit save, let's hit compile, and then we'll just run it. Oh, If ah, what is that? Where do we get that from? Plate P. What do we have at Plate P? Like, Plate P should have like nothing. Let's see what it's that. What in the world is ITH? Where did that come from? Number clean zeros, yeah. Over here, I'm just going to return weight first. And then see what do we have. If A. What is plate P? So plate P is weird. What? Where the hell did that come from? Over here, plate P is empty, and then out of nowhere we have ITHA. If this is that, like clearly right now we don't have that. So definitely we have this. And then plate R is now just 1. And as long as plate P is shorter than what it needs to be, keep on adding to it. Let's see, what do we have here? I'm going to say this is 1, this is 2. One, and now 2. Huh! So apparently, this one is sus. But why? Character set 0. That is very odd. So at least we know the problem is this one. So we can actually just remove all of these. Now we just have to figure it out what in the world it is doing right there. Okay, let's do a see out. And then let's see what's there. How is this thing converted to this? What? What? This is completely new to me. Let me check what does that has C++ if what does it says about that? Let's see. What if no way. So apparently, for some weird reason, when these two things are concatenated, you will get not 0, not dot, not 0 dot. You'll have if ah. Why? What? Why do we even... Oh. So I believe the only way to fix this is we need to use forward string convert character to string. What and why? I'm just going to document it. Or, oh lord. I'm just going to call this weird thingies that we do not know. Oh. Hey. By the way, thanks for the follow, Kuruku. How was your day? And also at the same time, we just found a really weird bug on C++. And today's date is 2024 11th 24, is it? Yeah, yes. For some weird reasons, we take the character 0, concatenate it with the string with a single dot. You will get if ah. There we go. That is so weird. I have never seen that before. I've never seen something like this before. Well, guess we have to do this the tiring way. So we don't need the C out anymore. We don't need that anymore because now we know how to fix it. So this time we really need let's just wrap it up with parentheses. Excuse me. And then we just do forward string convert char to string. There we go. Hit save. And then we'll just do compile. There we go. So we okay, so we come back here. We know 3 decimal places. 1 2 3 1 2 3, that's 6. We need 9. So 1 2 3 4 5 6 7 8 9. There we go. Perfect. However, what if I just go the other way around? So hit save. And then we'll just do just run. There we go. This is 1 2 3 4 5 6 6 and then 3. So 3 decimal places, and there we have it. Perfect. Nice. I wonder how does it take care of that though, come to think of it. Well, anyway, there we have it. So this means that, let's just say 25. Need some like weird numbers. Let's go 128. Right, this will give us a quarter, which is 32. I'm expecting that. 32. There we go. Multiplications. Let's go. So I would say this marks the completion for multiplication. There we go. Alright. Small break. Alright, break's over. Let's see. Next thing on the list, multiplication safe. In this case, this means that we're going to take care of like multiplying for both positive numbers and negative numbers. But before that, I'm just going to say, let's take care of addition safe first. So, over here, addition, we only take care about the absolute value of it. So, let's compare to whatever it is. Big and small, is it? Well, I would say subtraction safe take care of a lot of like weird thingies going on. So, we're just gonna say, hey, if anything is negative, we just throw it to subtraction safe. So I would say, okay, let's see. Oh no. Number is pos is neg, and then we'll just go in A. This will give us a boolean. What is it? 1. Oh, it's just 1. Well, it's just that. Okay. Afterwards, we have number. Oh no. And then is pos is neg, and then we'll just go in B, and then we just go with if any of this. Oh yeah. This gives us a string. Okay. If this thing is negative, then we will say, okay, we will see what subtraction safe will give us with in A, in B. Or is it? Oh, now we have to figure it out which one is negative. Oh Lord. Okay. Okay, let's not try to jump any steps. Let's see. A and B plus small and big. Okay. B plus S. There we go. Okay, there we go. And then we just go, if both of them are plus, minus, Excuse me. Plus, minus, plus, minus, plus, plus, minus, minus, plus, minus, plus, minus. Alright, for this one, we're just gonna say, okay, we already figured it out. And this one is actually just... Why do I have a feeling that subtraction safe has already taken care of that for us? Feels so weird. Okay, let's see what this says. Minus B. There we go. This is B plus S. Oh, which is actually okay. We already figured that out. Okay, over here we're just gonna say takes care whichever is bigger in magnitude and takes care whichever is pos or neg. There we go. So if that's the case, okay, over here I'm just going to say string in A. Oh, over here it's string in B. There we go. So no matter which one is bigger or smaller or whatsoever, if any one of them is negative, then we know we have a problem. So we're just gonna throw it for subtraction safe. In A, in B. This also means that else, if all of them are positive, then we're in good shape. No matter if any one of them is bigger or smaller. So we're just gonna say return addition in A, in B. Oh boy, very recursive. And you just heard from the BGM, one of my friends just said, no, recursion is not real, but you can mimic it. But once you mimic it, it becomes real in some sense. Result if error, there we go. So we have that. So now I'm just going to say something like really weird. I'm just going to say addition safe. There we go. Come on, catch up. There we go, good. So 64. Whoop. Now at this point, I just want this thing to be like, just give us 64 or whatsoever. Anyway, you know what? I'll go with 32. Also, there we go. Okay, hit save, compile, and then just run it. Huh. That should not happen. Huh. Okay, it's pauses nag. It will return any one of these. Huh. Result if error. There we go. So technically speaking, wait, let me do a comparison. (128) (-32). Oh, that explains it. Huh. Ah. That explains it. Because it just converts this literally to that. Huh. Interesting. Okay. Now I know how to fix this, I guess. So addition save is not exactly as easy as this. But at least we have this, which makes things a lot more easier. So I would say, let's do a boolean. I would say, in A is pause is nag, or I should say, in A pause nag. There we go. That should do the trick. Nope. I'm gonna do this. Whoop. Number. Whoops. Is pause is nag. There we go. Whoop, whoop. Bool in B pause nag is number. Oh. Yeah. Thanks for the follow, swag like Ohio. Yeah. Well, what we're coding? Well, okay, most of the time in C++ or any programming languages, when we want to just do arithmetic math, we just like simply just type the numbers and then just let it do the math. When the number is small enough, yeah, it works fine. But the moment when the number becomes big, it becomes out of range and uncalculatable. So string math over here is going to fix that. And at the previous stream, we have addition and subtraction safe. Now I'm just have to like make sure that our addition is safe, meaning if we're adding if any of the numbers is negative, we're just gonna throw it for subtraction safe, because subtraction safe just like, you know, take cares whatever number is bigger, or if any of the numbers are positive or negative or whatsoever. And also, just a few minutes ago, we just finished multiplication, which take cares of integers and floating points. Precision, it's the maximum available length of the string. Like, okay, you know what? Let's just check. So let's just see C++ string maximum length. Let's see, how long can a string be in C++? Oh wow. Oh wow, we're in good shape. We're in good shape. Oh lord. So now the precision, the maximum precision you can have is the maximum amount of memory that your program gets to have. So yeah, with this you don't need to like worry about like huge, big, wonky numbers. You just throw it for string math and then boom, it just spits out for you. However, it spits out it as a string instead of a value. I mean, a mathematical arithmetic value. Alright. By the way, what have you been up to? Also, I'm going to say in A is nag, in B is nag. So I'm going to do the comparison. If this thing is the same as this, is pos is nag in A, no, in B. There we go. Whoop. Here we go. So now at least we have that. Oh, cool. Well, you know, most of the time on Twitch, when you just search up VR chat, like, okay, some of them are playing games, good. Some of them are like talking with friends and all that stuff, yeah, good. But I would have to admit, half or a third of them are most of the time useless wiggle videos, and I do not like that. And so far, I have not seen anyone coding and by using the tag VR chat as well. So I was like, okay, like right here, over here, like you can just see that my avatar over here, like, you know, this is a con in VR chat or whatsoever, but so far no one codes. So I was like, all right, time to have some fun. Why not? But thanks. And just in case, the moment when you think something is like pretty cool, I would say, hey, you might be able to take a look at it when you are free, so that should be good. Yeah, true. That's only sad stuff. And one of the sad stuff that I realize is most of the really good content, like, I'm going to be a little bit cocky over here and just say most of the time when we have like really good content, not really many people watch us, but at least we have nice people, like maybe let's say including you and those who are still in the chat or lurking or whatsoever, come watch us, so that's good. But if you go take a look at those wiggle videos or whatsoever, 600 views, 700 views, sometimes 1,000, and I have literally no idea why. But fair enough. Alright, let's get back to this. So, I'm going to say if we have big plus small, Okay. Let's see. Oh! I was also trying to watch Blade and Sorcery streams, but the only two are streaming. Neither of the headsets were... Huh. Wait. Blade and Sorcery? Never heard of that. Well, let me search it up. Let's see what we have. Blade and Sorcery. Oh! Oh, that looks pretty cool. Ooh. Not quite sure if this is available on Quest. Huh. Interesting. So it's almost something like a fighting simulator. Okay. It's a VR wave fighter thing. Wave fighter thing. What do you mean by wave fighter? Is it something like the enemy just keeps on coming in waves or something like that? It's on Quest. I think it's called Blade and Sorcery Nomad. Oh. Oh no. Yep, it's right here. Yep, right here. Oh, $30. Huh. Interesting. Oh, you fight waves of enemies. Well, that explains it. Okay. Interesting. Huh. Just in case, is this game like still in development? Like meaning it is still updating, or is it like done, set in stone? Oh, just released into 1.0? Huh. So I believe it's like pretty fresh and new. Huh. Well, at that point they should like keep on maintaining it. Interesting. So just in case, so normally you also play VR chat as well? Let's see. There we go. There we go. There we go. There we go. Too poor to have a headset. Like watching VR chat stream costs a lot of time. They're pretty chill and get. Oh, cool. But just in case, do you have a laptop or a PC, just in case? Or, do you have a phone? Just in case. Because, like, right now what we have is, unfortunately also no, just my phone. Oh, okay. Is your phone an Android or an iOS? Android, perfect. So here's what we have. Here's something which might be extremely good for you. Ta-da! VR chat is available on Play Store. So what you can do is on your Android phone, you go to Play Store and then you go download VR chat. The best part, it's free. I already have that on my phone as well. So yeah, it's already out now. Like way before this update, all of us, we just want to play VR chat on our phone or whatsoever, until the dev says, alright, now you can have fun. Like, some of the people just rushes there or whatsoever and then just download it for whatsoever. So this also means that, hey, if you have an Android like what you have right now, then go ahead. Device isn't compatible. Huh? What? No. How come? Let me check. Let me check. Do we have bright mode? Oh, my eyes. Okay. Unlike Android 12, probably. Does it has anything about specs or something? Install on more devices. This app is available for a device. Let me VR chat on Android requirements. Hey Swag, you might want to take a look at this. Oh, how many RAMs do you have on your device though? By the way, this is not some like any weird blog post from someone else. In this case, this comes from Spark. Android 10 or higher. 6 GB of RAM. 4 GB. Well, that explains it. Oof. Just in case, under your circumstances, is it easier for you to get a new phone, or is it easier for you to get a laptop? Just in case. What? No, 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 no. Oh. Okay, tell me, how are you going to extend your RAM? Let me guess, is it some like weird software or something? That just says, alright, install this thing, press this button, hooray, now you have extra RAM. Is it something like that? Oh, okay. By the way, let me just make this thing. There we go. Okay. So here's the thing. Most of the software that just tells you, hey, I can give you extra RAM, that's actually bull poop. Because actually, here's why. First, we need to know what is the entire part of your computer or central processing unit or whatsoever, right? So in your entire CPU or central processing unit, you have several parts. The first thing is your registers. So registers, you can imagine them just like your little desk or whatsoever. Like, you can imagine that your register is like a box, and these box will just literally just hold numbers, just numbers. Like, you can store whatever you want. Like, you can store 8, 9, 10, 11, whatsoever, right? And then you have this something which we call it the ALU, which is the arithmetic logic unit, which this thing over here does the math. And then there's this like something called the controller, or is it program controller? We call it the PC, the program controller. So basically, what the program controller, imagine it's like, okay, like just imagine this entire whole thing is like a kitchen, okay? In a kitchen, you're going to have different stations or different plates. Okay, let's just call it this way. These registers over here are plates, right? And then let's just say this chef over here can just literally put any food on these plates over here whatsoever. And then this ALU over here is like a little working station. Like, you can chop it, or you can wash it, or whatsoever, right? Oh, let me see if I can send you the screenshot in the Discord. It's a pretty vague description. Oh! Let me look that up. Tell me when you get there. Hey, there you go. So far, okay, so just in case, since we are talking about software and all that stuff, we can actually go to computer science. So it would be, let's see. There we go. So just in case, you can actually post the image right at where I mentioned you. Tell me when you get it. So one thing about the whole RAM. Oh, you threw it on at the general? Oh, okay. Let me take a look. RAM expansion. When enough storage space is available, you can use part of it to expand. Huh. Okay. I'm going to put a bookmark on this, and then we will come back to that. Well, that's a big oof. But just in case, if we come back over here, the reason why I say that is bullcrap. Okay, here's why. Like, you can just start imagine that your whole hardware or PC or whatsoever is. I forgot to add a new layer. Oh lord. Can I delete this? Yes, I can. They take this thing, I splat it back black. There we go. New layer. Good. Alright. So for now, let's not think about in terms of like really cool fancy science term or whatsoever. Let's just use something that we can easily understand or whatsoever. So where is my brush? There we go. So here's the thing. in your entire kitchen, you have your plates, okay? And then you have your fridge, okay? You have your fridge. You have your cutting board along with your knife whatsoever. You have your sink. What? You have your sink whatsoever, right? And then there's you. And then other than you, you have your cooking recipe, right? So here's how you make a meal. First thing first, you just read through the manual, right? And then afterwards, you might go to the fridge and then you put some food on your plate or whatsoever. Let's just imagine anything you need to put on is on the plate or whatsoever. And then you just go through the manual, and then the manual will just literally just tell you, okay, you take this food from this plate whatsoever, maybe you cut it, you wash it whatsoever, and you put it some other plate or whatsoever, right? And then by the time when you are done with all of these steps, you'll end up with yourself with a bowl of salad or whatsoever, right? Okay, so let's just say if for some weird reason your kitchen is not big enough, so you decided, alright, you know what, I'm going to extend my domain to the outside. Like for example, maybe your yard, or maybe some, let's say your living area, right? For some weird reason you do not have enough space. Let's just say somewhere around over here. Here is your living room or living area. You have your coffee table, you have your couch, whatever works, right? Okay, so here's the stuff. Now, this also means that, okay, yeah, fine, sometimes you can actually put your stuff, but you have to move all the way from your kitchen, and then you have to go to your living area and then just put stuff whatsoever, right? And just in case, I'm just going to put it in a new layer. There we go. So now we can actually start to match things up. Like most of the time when you just literally go online and just search what's a register, what's a RAM, what's a storage, what's an ALU, all that stuff. So here's the thing. These little plates over here, because they can store little stuff, in this case, they will be your registers. Registers are designed in order to hold numbers temporarily. However, they are really easy to access. Just like you're in your kitchen, you just simply just wobble all around and just grab the plate whatsoever. Easy, nice, and quick. It's quick access, okay? And then sometimes, let's say you have two food. Let's say you have, mushroom on this plate, right? Let's say the recipe tells you, alright, slice them. So what you do is, you take this mushroom, you put it on a cutting board over here, you slice it whatsoever, put it back over here whatsoever. Now, this cutting board over here, or maybe this sink over here, when sometimes you need to wash it or whatsoever, everything over here, alright, it's your ALU, or in this case, arithmetic logic unit. In this case, in the world of computers, the ALU lets you do math, like addition, subtraction, multiplication, division, all that good stuff. Okay? Now, the fridge over here, okay, I would say it's a little bit far away, but at least you can get it. What is in the fridge? All the food you can have, right? You can put food inside your fridge, like your leftovers or whatever you're about to cook or whatsoever. You can take it out, you can put stuff in it whatsoever. And typically saying, this will be your storage space. Okay, your storage space. And how big can your fridge be? It's how big your fridge is. So next time when you hear someone says, "Hey, I'm going to give you a magic mushroom such that it can make your fridge go bigger," you know there is no such bull crap that it can make your fridge go bigger. No, it can do. It's just gonna take up more space in your fridge, and that's it. So typically saying, in the world of PC, this is your hard drive, or let's say on our phone, in this case, this will be just our storage. Now, what about RAM? RAM is something like extra part of like storage. Like for example, alright, you decided for some weird reason you have a lot of stuff, so you decided to put it at the living table, like at a coffee table or whatsoever, right? Yeah, you can access it, and then the table is way much bigger. Wait, living area table? Wait, I got a better idea. Instead of the living area table, we just say the dining table. How about that? Dining table is way much bigger and also available to the kitchen. Okay, let's do it that way. The dining table. So you can just put a lot of stuff on the dining table, and then you can also access it as well. It's just a little bit further away from the kitchen, so it's a little bit slower. However, it's way bigger than these registers. So let's just say, for example, alright, I have a couple of dishes. You just finished the salad, you put it all at the dining table. Now you're gonna work on the second dish whatsoever. Work on it, put it over here whatsoever. So typically saying, this dining table over here is your RAM. And once again, if somebody tells you, "Hey, I have a special food such that I can make your dining table bigger," you know, that ain't real. That ain't real. No, that is sus. No. Which is actually the same as most of the software says that, "Hey, I'm going to give you extra RAM." That is actually bullcrap. Okay? So that's not gonna work. So how are you going to get extra RAM? The way that you're gonna get extra RAM is you literally need to buy more hardware and then attach it to your system. Like on a PC, okay, you can actually just buy a RAM and then attach it to your motherboard or whatsoever. You definitely saw those videos, or maybe you just search online and just search RAM or whatsoever, right? But to be honest, I have no idea how you can do it on the phone though. Taste colors, see sound, let's go. Oh no. Yeah. So yeah, this is actually how RAM quite works. Basically, when your little program is running, it's running inside this RAM over here. Every program you're running, it's running inside this little RAM thingy. Okay? This can include your recipe. This can include your recipe. Okay? This can include some variables. This can also include some dynamically allocated memory or whatsoever. Right? Like for example, you just decided to like, "Oh wait, I got a phone call, but I'm at the dining table. Alright, I must make this right here and I'll come back," or whatsoever. Right? So yeah. So without further ado, just to see what do they really look like. We can just search it up and just search RAM, right? Oh, come on. Oh. Computer RAM. There we go. So we just take a look at some examples. See, this is what a RAM looks like. So basically, these little chips or whatsoever, they hold stuff. And just in case, when the power is on, okay, it is still there. The moment when you turn off your machine, everything inside this thing is vanished. It's gone. Vaporized. Daft Punk album. Well. Oh well. But yeah. So just in case, every time before you turn off something or shut down something, you save your stuff to the storage. Like, you still remember, like, back at the kitchen, right? Every time when you're done cooking, your mom's gonna be like, hey, clean up everything, right? So you just store everything, right? You just start storing everything into your fridge, on the dining table, whatsoever, or you just give it to your neighbor or something. You have to keep your kitchen clean, or otherwise your mom won't be happy about it. Even when you're done eating at the dining table, you also have to like clean up the table, right? So yeah, we have that. So this is a quick metaphor of hardware in PC. So the next time when you see any program saying it will give you extra RAM, nah, ain't buying that. Alright, so getting back to the screenshot. Okay, screenshot says something like, when enough storage space is available, you can use part of it to extend your RAM. From, okay, to me, this does not exactly somehow sound 100% right, but the way that I can interpret is, if you still remember the fridge, right? This fridge, let's say, this fridge is your storage or your hard drive or hard disk or whatsoever. And then you have your dining table, right? What your screenshot says is something like, if you think your dining table is not big enough, and if your fridge still has space, what it might allow it to do is to say, alright, I'm this external program, I'm going to use your fridge, a part of your fridge, and let it act like a part of your dining table. So now you have a slightly bigger dining table, but actually under the hood, it's actually inside the fridge. So that is the only way that it can make sense to me. But I have no idea how does it exactly do that. But yeah. It has options to extend it by 1, 2, or 3 gigs. I wish it was an external program, at least then I could delete it. I would say every program on your phone downloaded from, let's say, Google Play Store or whatsoever, must be able to uninstall it. Otherwise, it does not fit the rules. So yeah, just straight to my settings, huh? But just in case, have you tried to use this method to quote-unquote extend your RAM before and then try to play VR chat? No, this is the first time I've seen it. Oh. Okay, so since you say you have 4 gigs, you know what? Let's try 3 gigs for safety and then see what it does. But I cannot guarantee that it will work. I cannot guarantee that. And oh wait, you didn't know that? Oh, okay, cool. Well, now at least now you know VRChat is now available on mobile, so that's good. You don't even before you go to the store, have you quote unquote extended your RAM? Alright, let's see. Negative, 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 negative. There we go. And it just negative all the way down. Oh. No, still not have enough storage. Call for duty mobile is well, you know what? Let's compare it. Let's see. Okay. Call of Duty. Alright, let's see. Call of Duty mobile size. Let's see what's the file size of that. 12. Oh, huh. I don't know whether to stick with 12 or 3. Huh. Oh boy, I don't know what to look at right now. Oh boy. Okay, what about VRChat? Let's see. But I would say, to some extent, VRChat is actually quite minimalistic. Alright, fine, let me see. The initial game is 3 GB. There's a bunch of resources to download that at one point took up. Oh lord. That's way too much. So just in case, you only have one phone? Huh. Okay. But you said you're working on trying to get a job, so what kind of job you're looking into, just in case? That explains it. Yeah. Sounds about right. Okay. So just in case, if you do not, so if you don't mind me asking, keep in mind you can choose to reject to answer this thing. Do you live by your own, or do you live with your parents, and your parents do have a financial income? It's just not exactly that quote-unquote quick. You can choose to reject to answer if you don't feel comfortable answering it. Oh. Okay. I see. So we're still working on it. Okay, I got it. Well. Good to know. Oh, just in case, when you're able to find a job at a fast food restaurant, you can just like tell us, so at least we know, hey, you're on your way onto VR chat, so that's good. Just in case, for curiosity's sake, I wonder. Oh Lord. Okay, assume that this is the thing that you're aiming for. Let's count that as 200. And then, for example, let's just say you work at McDonald's. Okay. Huh. Why does it give me that location? Oh, it doesn't matter. Okay, fine. Let's just assume that it is 13 something. 10 for an hour. Huh. Okay, so in this case, let's just do a little bit of like simple math. 10.25. Let's assume that that is 10. 200 divided by 10, you get 20 divided by 1, so that's 20. You will need 20 hours. 20 hours in, okay, in a single day. For how many hours do you need to work? Because you will need to work 20 hours in order to get a phone like that. There you go. There you go. There you have it. After 2 pay period, you're there. There you have it. So I would say, this will be your goal. This will be your very first goal. Okay? Like different, like okay, here's the thing. If you think I have a nice PC that I'm streaming right now, nuh-uh. I'm having a potato laptop. I do not have fancy PC setups or whatsoever. Nah, I only have a potato laptop, but it's a very good starting point. Hey, and just in case, I also have my own income as well. And yeah, I got myself a Quest 2, so yeah. That took me like 4 months or something. Can't remember. But yeah. Oh, data. Oh. Well, that explains it. Yeah. Sounds about right. I forgot the data plan. Ugh. That thing does not look good. But yeah. So, I would say, the moment when you buy it or whatsoever, at least ask how many real RAM it has. And make sure it's higher than Android 10. You don't want to waste your money. So yeah, we have that. Alright, back to this. Let's see. This one's okay. This one's okay. So at this point, I can just simply just ask if where is it? Number compare ABS. Okay. Number compare ABS. In this case, in A, and then we have in B. Data isn't that bad. T-Mobile has a plan for $30 a month. That looks pretty good. Huh. Because, wait. T-Mobile data plan. Let's take a look. So, for every month, how many data will you get? Let's take a look. Just in case, where do you get oh boy, where is it? Is it this one? Okay, let me just search data plans. Well, it doesn't shows up the thing that I'm looking for. So what I just want to find or know is, for that plan you have, how much data will you get for every month? Unlimited. Unlimited for $30 a month. Let's take a look, because I use Mint Mobile. Let's take a look. Because the moment when you say 30 bucks, the first thing that comes to my mind is, wait, this one is 15 bucks. So the only variable that it can be like, why makes it 30 bucks or what makes it 15 bucks is how many data you have. So just in case, let me check. So I wonder how much data do I have? Let's take a look. Ah! Huh. Oh, new customer. Or is it? Oh. Interesting. Yeah. This is like 3 months. So this means that every month is 15 bucks. Huh. Interesting. But why some of them are 20? Some of them are 25, some of them are way... What is the reason? Well, I don't know, but if possible, you might be able to like just... Oh! If I remember correctly, there is actually... Oh, you can just actually just ask them, huh? The help center. Let's see. Well, you know, if you want to know more about it, go ask them stuff. See, are there like any like weird funny stuff? So yeah, one is 30 bucks, one is 15 bucks. Are there any hidden features or any stuff? I don't know. So yeah. Back to this. If A is bigger or whatsoever. So back to this. Now we just come in here. We do else. Funny stuff is a 300 upfront charge for 12. Yeah. Well, I'm not a finance guy, so I have no idea how did that work or how did they come up with that number. Now, over here, let's see. Alright, so this one will take care of the first group. Okay. So if in A is neg, now I would just say pause neg or whatsoever. and then this will be a string. This will be another string. So either it will give me a negative sign or a positive sign. There we go. Yeah, fair enough. Like every time when you watch YouTube, he just pops up. And the sad thing is, you have to watch 5 seconds of it. You can't skip that, which is sad. Yeah. In a pause neck. There we go. It's a minus. If in a no, this time in B pause neg. It's also this. Else if in B pause neg, and then let's just go whoop, 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 and then just go whoop. There we go. 1, 2. Okay, so that looks pretty good. Oh, there we go. And then we just copy and paste the whole thing. There we go. So if both of them are positive, we don't care. Just straight addition. Here we go. If we have this one, which is basically okay as well, because this is actually just subtraction, but the vanilla one. We do need to like strip away though. So we can just do number. Strip. Let's go with in B. And then the direction should be the head. So we just need that in order to remove the negative sign. So that should be good. Alright, that takes care of that. Next is this. Okay. So basically this becomes S minus B. Yeah. So in this case we need subtraction but save. So this time is in B and then in A. And then we can just say return this thing. Oh, or otherwise we have this. Negative B minus S. Yeah. Almost about the same thing, but this time it's A and then this one's B. Hey. Hey. Okay, so we have that. Good. Positive, positive. Okay. There we have it. Which in this case will just return simple addition, which is the one we have taken care with. The next thing is this one. S minus B. Huh. So in this case, we will say return subtraction save. In this case, we need an A, and then okay, subtraction save also take care of stripping and all that stuff. Yep. So wait, if that's the case, huh? E. Yeah, looks pretty good. Okay. E. Alright. Next one, which is this one. So this one is actually just B minus S. Okay. So over here we can just say return subtract. Let's go with save. Yeah. And over here we will say in B, and then we will say number strip in A. This time strip the head, so no more negative sign whatsoever. And then finally we have this last one, which is negative S minus B. Return subtraction save. So in this case, it is still in A, but this time we wanted to do some number strip. There we go. Number strip in B. There we go. And then else if they are the same size, wait. Okay. They're the same size. it means if in a post neg is a positive one, and we can say else if in a pos neg is negative. Then we can also do the same thing. So if we say in B pos neg is positive, or else in B pos neg is negative. So we have that. Oh, well, expected it. Oh, okay, we haven't reached there yet. So we're gonna paste it right there. Okay, cool. So if both of them are the same, then doesn't matter. We just do addition in A, in B. If they are the same, but one of them is negative, then we're just gonna simply just return for string. Come on. IntelliSense is not IntelliSense anymore. Convert char to string. Character set. Return 0. That's what it is. Or the same happens here as well. Or otherwise, negative minus negative. It's actually the same thing though. But I would say we need to strip it. So number strip the head, number, strip, and then strip the head as well. But attach that. There we go. Or otherwise, just return result if error. There we go. There we go. Else if. That's more like it. So if we come back over here, so over here, I'm just going to post. Okay, I'm just going to paste some testing case over here. And then over here we have 32, 28. Whoop, whoop, whoop. There we go. Plus plus minus, 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 minus. And then minus over here, minus over there, minus over here, minus over here. And then hit save. There we go. So first thing first, yep, that's correct. And then that looks correct. Nope, that did not get it right. So we take a look at which are the wrong ones. This is correct. This one is wrong. This one over here, yeah, looks correct. And the last one, yep, that's correct. Okay, so we have the last two and then the second. Okay, let's take a look. Last two and then the second, which is this thing, and then the second. Okay, so over here, if A is negative, oh wait, A, oh yeah, this is over here. Oh, for A I need to like strip off as well. Okay, got it. So number, strip. There we go. Strip off the head. There we go. So now we have this. Oh, which is the same situation over here. Number, strip. There we go. And then we have that. We have that. We have that. There we go. Okay, so that takes care of that. Now, this one. Okay, for B, we need to like strip it off. Okay. Number, strip. H, there we go. And there we go. Alright, time to test this. So if you just take a look at this again, 160, okay, 96, yep, negative 96, yes, negative 160, perfect, 160 again, good, Negative 96, good. Positive 96, good. Negative 196, there we go. So now addition can also take care with negative numbers. So that's good, yay. Okay, multiplication. This also means that we need multiplication safe as well, but I believe it's like pretty easy, I suppose. So let's do this. So multiplication safe string in A, and then we also have string in B. First, we don't need to care like if any one of them is bigger, doesn't matter because it's what was it? Commutative again? Oh boy, I cannot remember what's the perfect term for that. Alright, let's see. So in string in A pos neg is number is pos is neg in A. This one over here in B pos neg number is pos is neg in B. Okay, so we can say if this thing, if both of them are the same, then we're good. Else they're going to be negative. So in this case, we're just going to get the absolute value of it. So let's just say string. Okay, wait. Do we have that? Oh no. Okay, let's see. String number get ABS. So string in string. So this means we will get the absolute value of it. So we can say if in string at 0 or length is bigger than 0 or otherwise, meaning it is really is 0, meaning an empty string, then we just simply say return for string convert character to string, character set the 0th one. There we go. Or you know what? I'm going to do this. String. I'm going to call this thing number. I'm going to call this short and 0. It's just gonna return this. So this means if I found any of these, let me just crop that, paste it over here, and then we have a whole bunch of them. We know we can actually just replace with just this. Go through all of them and then just boom. So that makes it cleaner. Alright, cool. So this basically translates to forward, the string, the convert, the manip. Wait, no. Char to string, character set, 0. There we go. So there we have that. Get absolute. So that would be say if in string dot at 0 is this, then we're just gonna say in string okay, if in string length is perfectly 1, meaning it's just the negative sign, then same, return this. Or otherwise, strip it, remove it. So it will say forward. Oh wait, no. Number strip. Can we use number strip over here? No, not yet. Oh, okay. So we have to use forward string manip trim safe. There we go. In this case, in string, starting from this until in string dot length -1. Here we have it. Whoop. Dot length -1. I thought I have it. There we go. Yeah. And then we just say return. So let's test this thing. Number get absolute. And then we're just gonna copy and paste a few of these. In this case a 0, in this case a dot, in this case 0 point, In this case, 0.0. In this case, -0. In this case, -0 point. In this case, I'm going to say -0.0. Just negative. -1, 2, 3. -1. -0. Oh boy, this is going to be wonky. Okay, I'm going to expect errors. Huh. Result if error. Let's hit save for that. Multiplication save. Oh, we don't have that one yet. Oh wow. Why does it has? Huh. Alright, let's take a look. What do we have? First one just says error. If length is bigger than 0, yes. Oh. Else we just say return in string. Okay. So just compile it and then see what is the new result. Oh, okay, there we go. 1, 2, 3, yeah. 0, okay. Point. Okay. 0 point, okay. And the rest is just a whole bunch of zeros until the second last. Alright, let's check. 0, 0, 0, 0, 0, 0, 0, 0. Second last. Alright, good. 1, 2, 3, 1, and 0. Oh, there we go. Perfect. But what about an empty string though? Let's give it a test. Yep, also a 0. Perfect. So this means that we can use this to get absolute values now. So if that's the case, I would say maybe this becomes a lot more easier to deal with. Right? Oh boy. But yeah, whatever. Multiplication safe. Alright. Let's see. In this case, over here I'm going to say string in a ABS will be number get ABS of in A and string in B ABS. Number get ABS in B. And easy enough, we're just gonna go string. We just go ABS result is multiplication in A ABS and in B ABS. There we go. So now ABS result will have the absolute value of it. Now it's just we don't know if it's negative or not. So if both of them are the same, then we can say ABS result will be a negative sign attached plus itself. Oh wait, no. No. Let's just cut this thing and then just paste it over here. Or, you know what, let me just cut this thing and then over here I want to say return this. Or otherwise, return it with a negative sign. So hit save, and then we'll come back to here. Now we'll just come over here, and then we can now say multiplication safe. Let's go with some number that we know. Let's say 12 and fine, let's go 25. So assume that we have this. And then over here, let's just swap it around, 25 by 12. So over here, and we're just gonna say negative, 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 negative. And then also here, we're going to say negative there, negative there, negative there, and negative there. There we go. And then we're just gonna hit save. And just in case, if any one of them is a 0, no matter what. Yep. Let's say if the first one is a 0, second one is the 0. There we go. Like whatever we have, it will always be 0. We just need to like make sure we have no funky stuff going in there. So negative 0, negative 0, negative 25, negative 25. There we go. There we go. It's safe. Run it. There we go. So if we take, alright, let me pull out my calculator just to see. 12 times 25, so that's 300. Yes, alright, good. 300, negative, negative, positive again. Alright, good. Positive again. Alright, good. And then negative, negative, positive. Good. And then a whole bunch of zeros. With some of them are negative. Okay. Okay, that's kind of good. Shall we do some cleaning? Let's take a look. Let's clean zeros. Also take care with negative stuff. Hmm. Alright, let's see what will happen when we clean the zeros. So, over here. Hmm. So, number. Clean 0. So we have this. And then over here we'll just have number. Clean zeros. We'll have that. Save it. Compile it. Run it. It doesn't care about that. Well, I guess it's... Never mind, I guess. Let's take a look at clean zeros. Let's see. Is there a dot or decimal point? Okay. Just in case, let's call this number. Let's call this thing clean format string in string. So round 1 is like number clean zeros. So string, let's call this thing pass1, and then I'm going to call this thing number clean zeros in string. Okay, another one is clean neg zeros. Just in case. Okay, now I just wonder, what if we have a long 0 but we have a negative sign in front of it? What will we have? So number clean zeros go. There we go. Alright, let's see what will it give us. Okay. It doesn't take care of it. Okay. Wait, I think I have an alternative idea. Cleaning next. Okay. I'm gonna call this thing string number clean zeros 2. Just like how we just replaced the previous one. So now the new idea is I'm thinking from a compiler situation, like, okay. The main idea is something like, let's just say we have a whole bunch of numbers. Let's say 000, 123, 000, point, 000, 456, 000. What I can do is I will need to put a hashtag, something like that, at the front of it and at the back of it. So now every time, if inside the string I see a hashtag 0, I'll replace it with a hashtag. Every time I see a 0 hashtag, I will also replace with a hashtag. This means whenever the hashtag hits a non-zero character, then I know that hashtag can go away and the job is done. And if there is a negative sign at the front, every time when I see -0, I can change it to a negative sign. And so on. Okay, let me do this. So I'm going to type it. Main idea of this function is to attach both sides with a hashtag. For every iteration, if a hashtag 0 is found, replace it with a hashtag. And then I say if a 0 hashtag is found, replace it with a, there we go. Where is it? There we go. Whoop. Also, let me hit close on that thing. There we go. Also replace it with a hashtag. And then I can also say if a -0 is found, replace it with a negative sign. There we go. Okay, good. So first thing first, I need to set up some constants. Const. Can I use this? Huh. Hashtag 0. Or I just say H0. Okay. Oh wait, what if the character? Oh no. Let's see. Well, one thing I can definitely do is... Oh wait, no. Okay, I'm going to say... Okay, I'm going to say something like... Character... Negative... And then this one I will say character mechanism. So over here maybe I can say vector character mechanism. For now, I can only think of hashtag is the only one that I'll use. Hey. So in this case, this also means that I will need to like search through all the negative signs. For functions, oh no. Okay, for functions. Nope. Lower. Nope. String math. Whole bunch of them. Test. Nah. Alright, let's see. Oh, what's this? Nope. What's this? Nah. Return this. Okay. In this case, I would say character neg, which means it's the character used to represent if a number is negative. this case, by default, it's negative sign or whatsoever. So, yep, we have that. Looks pretty good. Oh, what's this? Oh boy, now which one do I know? Oh boy, I don't know which one it is though. Number is plus nah equals that. Nah. Return this. Okay, yes. Plus nah is that. No. Return this. So yes. Return this. Yes. Return. Oh wait. No. Return this. I would say yes. Yeah. Final one. Comparison. Yep. Okay, cool. Okay. Boop. Boop. And then boop. So over here. Now we let the users decide, okay, what's the character is. So string of this. It's actually just okay, so for the string the convert the character to string, which is character mechanism 0 plus let me change one thing. Shorthand 0 set 0. There we go. There we go. And then over here I can just say almost the same thing. It's just instead of set, this time is mechanism. And over here, we're just gonna say int index. So character mechanism index. There we go. Which is this one. This one over here is not for like any arithmetic calculation. It's for debugging or mechanism or processing or whatsoever. So this means that both of these sets cannot be the same. If they are the same, if any of the elements are the same, you're going to expect errors in it. So we have that. So this becomes string const h0 is number shorthand mechanism 0 plus number shorthand set 0. So yeah. And another thing that I would say pretty neat is I'm just gonna like simply take this thing, put it over here, and there we have it. And then over here I can just say int index, and then just say index. There we go. So okay, we will update that afterwards. Over here we also have string const, but now it's 0h. So which is the same thing over here. Copy, paste. There we go. Const negative and then 0. And then we do this thing over here. Shorthand neg. Whatever it will do, it will just say character neg. There we go. Convert that character into a string and then give it back to you, no matter what. So ooh. I believe there are a lot of stuff. That one's fine. That one's fine. And then for this one, I'm just going to say number, shorthand, neg. Which is a thing up here. Number, shorthand, neg. So, yep, that looks good. That looks good. That looks good. And that looks good. That looks good. Yeah, that will give us a string. So, yeah, that looks good. And then, let's see. Okay. Let's see. Let's see. In this case, I'm going to say number, shorthand, neg. And then over here, I'm going to say, wait a second. Instead of number shorthand, I'm going to say, character. Yeah, that seems better. Number shorthand to character shorthand. Yeah, that's better for categorization. Oh, newer cosmic. Coding. Okay. It's what I call string math, which is, oh boy, how should I say this? Most of the time when we are like coding stuff, we want to do like math or whatsoever, we will use something like the data type, like int, float, long, whatsoever, right? When we're dealing with numbers that are small enough, yeah, it's fine. The moment when it starts going wild and wonky is when you start to have like dealing with like really big numbers. And this is actually what string math is dealing with. Really big, wonky, weird numbers. So this basically means now that your available precision is your entire memory, because according to Google or whatsoever, the maximum length of a string variable can be is your entire memory. So yeah, that becomes your new precision now. So basically it's almost something like it's doing human arithmetic and it just spits out a string back to you. It's almost something like pencil and paper math, but on computers. So we have that. Number shorthand, character shorthand. Yeah, that looks pretty good. Do to all of them. Boop. Hoop, hoop. So, character shorthand neck plus character shorthand 0. And I would say this one has that. There we go. By the way, how things are going on your side though, Cosmic? Let's see. Let's see. Forward.string.detect. Contain string. There we go. Perfect. Input. Okay. So at this point, I'm just going to say string plate is in string. Whoop. There we go. Plate. String target. So basically just see if it contains any of the const. Or there we go. So in this case, I just need an if statement. There we go. Let me cut this thing and then paste it right here. Whoop. There we go. Let's see. You can just copy and paste this whole thing. So, whoop, whoop. And basically, this is actually just a while loop, though. Yeah, we can do that. H0 or 0H. Oh wait, you still need more stuff? What is it asking for? Start from, oh. Start from left. Okay, so there we have it. If it founds it, it gives us the position. Huh. Ooh. Okay, so in this case, I'm just going to have a bool and just call it job done. For now, it's false. So I'm just going to like cut it and then like paste it over here, and then over here I'm just going to call this thing when job done is not done yet, then keep on doing it. So we have that. So over here I can just nope, there we go. Over here I can just say int the position of it, pos of n0, and then int of pos h0, and then int of pos 0h. And I'm gonna hit save, because sometimes all of these wonky stuff is caused by you know, whatever. They'll say it's ambiguous, but no, it's just you're not ready yet. There we go. Whoop. When job done is false, get all the positions if pos this thing is equal that, and pos h0 equals that, and pos 0h equals that, meaning there is nothing to crush down now, meaning it's done. So we can say job done is true. But okay, over here we can just say else. We know there's stuff to do. First thing first is if pos this thing is not -1, then we know there is a negative sign along with some 0 with it. And we know the negative sign will always be at the front, so we know this can be compressed. So over here we can say plate will be forward.string.manip. Can I do replace? Yes, I can. Good. So in this case, I will be replacing something from plate. The target is -0, or in this case const -0, and then change it to the negative sign. So in this case it would be character shorthand neg. There we go. So we have that. And then we'll keep on doing this. And then, yeah. And then we can also say if pos of h0. Oh wait, I almost forgot one thing. Over here I'm just going to say character shorthand mechanism, the 0 plus character shorthand mechanism 0. There we go. So that will give us the 0 of character in character mechanism. Okay. If this thing is not -1, meaning we can crush something down. Let's see. Copy, paste. Wait. Looking for a H0. Then we're looking for set 0. There we go. Otherwise, if 0H is there, also replace it with that. Keep on doing this, and then I would say the first pass is done. So over here, I would just say, okay, return what you have on the plate to me. And I'm not going to expect that this will deal with any wonky stuff that we've found, but it will deal with the majority of them. Once we handle down like all of these stuff, like the main majority stuff, then we can start handling those little wonky stuff. Okay, so let's hit save. Now the test. Wait, this is clean zeros number 2. Oh, okay. No, it will not work. Nope, I have to compile it yet. But like, you need to compile it first. Whoop. There we go. Still, I haven't removed the hashtags and all that stuff yet, but at least... Okay, yeah. Good. Okay. Good. Okay. Okay. The last one is a little bit suspicious. Huh. Let's see. When we find this... Oh! My bad. This one should be character mechanism. The 0th one. Character shorthand mechanism. Also this one. Let's hit save. Okay. Yeah. Let's compile it, and then let's see what it says. So now we have that, which looks actually pretty decent. Okay, cool. So let's go to the test. Alright, so basically we have a whole bunch of weird wonky stuff. Now let's test for some normal stuff. So over here, we're just gonna say 1, 2, 3. And then over here, we're just gonna put another 0 on it. 0 on it. Now, that way. There we go. And then we just say 0.000. And then we're just gonna say 0.000. 000, and then we're gonna say maybe something like this, or maybe something like that, right? And then Control C, Control V, there we go. Alright, and then over here, we're just gonna say cout and 9. Save. Alright, time to go compile and see what do we have. Let's run this thing. So, over here. Hey, looks good. Looks good. Oh no. Oh no. Oh no. Yeah. Okay, I forgot that. Let's see. Alright, we need to give it a decimal point if no decimal point has been found. So, we say if forward.string.detect.character position in string character target is our dot. What if our decimal point can be anything else? So over here, let's go with char. Let's go character dot. For now, it's that. Okay, so we can come over here. And then we just say this thing we find is actually just that. So let's paste it. For functions, nope. And then just look at this. We have. Okay, we don't need that. Okay, for now, let's not do that because we still need to convert it into a string. So, just like the others, we can just copy, paste, shorthand, dot. There we go. So we have that. Now, character shorthand dot. There we have that. Whoop. For functions, nope, we don't need that. There we go. Declaring it, nope. While in string dot index is not that and that. Okay, sometimes we still need that. Okay, we'll see. Nope, not that. Find character position. Nope. While in string. Okay, let's take a look at this. Don't need that. Find char pause, find char pause. Ah. If this is that. Oh, okay. So we definitely don't need that. Don't need that. Don't need that. There we go. However, we need this one. Yeah. Find char pause. Oh, okay. Find char pause. We don't need that. Over here. Okay, we need that. Is equal to get lost character. So it's comparing to the character. So we don't need to change that. Don't need to change that. Plate R is this thing plus that. Okay, we need to change that. Find car post. Okay, don't need that. Concatenate. Yes. Find car post. Nope. Concatenate. Yes. Comparison. No. Comparison. No. Get lost character is equals to that. No. No. Plate R. Okay, that is concatenation. Then yes. This is comparison. So we say no. Okay. Now we do the same thing again. So it's a whole bunch of stuff. This time we will just literally just say character dot. Not in forward functions, we do not need that. So over here, nope, there we go. While this thing is that. Okay, good. Yeah, we need that. Detect find car pass. Yep, yes. And next is this. Alright, find car pass. Yep, find car pass, car pass, car pass. Lost car, lost char. Car pass, car pass. At. Lost char, lost char. Yep. There we go. I wonder if we're gonna find more though. So, whoop. Now it's only in here. Oh, yeah. Alright, that looks pretty good. Plate is over here. E. Let me hit save. Sometimes we just have to like wait for it to like pick up. Hey, there's a name called plate. Find character pose. Starting from the left. if we can find a dot, meaning its position is not 1, I mean -1. Oh wait, if we cannot find 1, then we can say okay, I'm going to say plate. Started with the in string. If we cannot find 1, we will give it 1. So plate plus character shorthand dot. Or for short, let's just go with that. Yeah. And then afterwards, we just have that. So at this point, all of them will have a decimal point. We will see afterwards. Okay. What? Compare ABS. Oh, okay, got it. Character shorthand dot. In this case, character shorthand dot is actually a method, so it needs parentheses. So, yep, change all of them. Unless, wait. Oh, this one is the declaration. The other ones are function calling, which is the one we need the parentheses. Hit save. Recompile, and that should be good. No? Fine, let's see, what do we have? Or let me hit clear and then compile it just to get a fresh error list. Huh, we don't have any. Okay. So let's take a look. Back over here. 1, 2, 3. 1, 2, 3. Find car pass should be 0. Should be -1. Find car pass. Character dot. In string. Let's go with plate. Adjusted plate. Over here we will say plate. Hit save. we go. There we go. 1, 2, 3. Yep, they just have that. But why? How did all the zeros get munched away by dot hashtag? Negative and 0, hashtag and 0, 0 and hashtag. Okay, over here I'll just gonna say whoop, and then just say barrier. Okay, there we go, hit save. There we go. So now we can compare it iteration by iteration. This is what we have. Yep. Third one. Okay, at this point, let's just not care about these. And then just take a look. Okay, there we go. Compile it and then run it. Let's see where does it goes wrong. Well, the first one is pretty easy. Second one, pretty expected. Wait, what? I just added that though. In the string over here. Huh, that explains it. Okay, compile. Just run. There we go. So, yep, there we go. Oh. Third one. Okay. Pretty good. Next one 0.123. Yep, expected. Okay, good. 0.0. Okay, so we have that. Yeah. Okay. Okay. Okay, yeah, good. Okay. Uh-huh. Okay, looks pretty good. Alright. Okay, so far looks pretty clean. Hey. So I would say pass 1 is done. Now we just need to throw some negatives into it. Let's take a look at this. Okay. Okay. Okay, good. Okay. Pretty good. Huh. Okay. There we go. Okay. Okay, good. Okay, looks pretty good from the looks of it. Just in case, just want to like make sure. You just make sure it just works. So let me hit save. There we go. Yep, looks pretty good. Okay. Now, sometimes we'll just end up with hashtag minus and then point. Right? So basically over here we are done with the first pass. So over here we are done with the first pass. So I'm going to say what kind of things that we might able to find is we have this. Oh wait, what if I just what if I just gave them a 0. And then a negative sign, and then a dot. Negative that. Or maybe a 0 dot. Or maybe a negative dot. Or maybe all of them together. Negative 0 dot. Or maybe negative dot 0. Or maybe let's just say empty string. Alright, let's see what they'll say. It's going to be wonky. So, this one gets it. This one's a dot, okay. It's also a dot as well. Okay. Alright. So let's see. So, okay. Let me remove this. And then I'm going to call this thing part, or I should say step 1. Decimal point giving. There we go. There we go. And over here I'll say step 2. Crunching iteration. And then I'll call this thing step 3. Wonky format fix. We may end up with the current situation at this point. So the first thing that we can see definitely clearly is that when you have an empty string, you just end up with this. Or if you start with a 0, you also end up with that. Okay. You have a negative sign, you'll end up with something like this. We have seen this, we have seen this, another this, another that, another this again, and another that again. Um, or yeah. So basically, we just see weird stuff like this. So we need to fix it. If forward dot string dot contain detect contain, and we know the hashtag is going to be at the start of the string and at the end of the string, so then it cannot be more than 2 hashtags, so it should be good. Everything should be in between the hashtags, nothing before, nothing after it. Okay. If our plate contains the following string, for example, oh wow. Let's see. So we could end up with character mechanism 0 plus character shorthand dot plus character mechanism. There we go. If our string contains this, and then start counting from the left, then we know we end up with a weird wonky string, and it should return a 0. So we can then say plate is 0. We then return that. Or else if it's what we have above, but we ended up with something even weirder, which in this case here we go. Oh, and then the negative sign. So mechanism and then negative sign and then the dot whatsoever. So character shorthand neg. There we go. Plus. So if we have this, then we also say okay. You also have 0. Or otherwise, you're good. This means we need to strip off the hashtags and then just give what is in between. So in this case, we can say plate will be forward dot string dot manip dot trim save plate. There we have that, starting and then until the end of it, which is plate dot length minus not 1 but 2. There we go. So we're gonna hit save. Now let's see it in action. Oh, let me go with this. There we go. Recompile. There we go. Good old zeros. And then for those who are proper enough, like this one, yep, they should get their numbers. Nice. So there we have it. Clean format. Okay, let's not have that right now. And then also, since we have a newer version, this will be gone. And then this means this will become the new one. Hit save. There we go. Alright, so now we have that. There we go. Hey. Multiplication save. So just a quick review of what we have done so far today. We have finally done multiplication along with a whole bunch of fixes. So let's do one example. So let's do multiplication, save. Let's give some wonky numbers. Let's go with 1, 2, 3, 4, 5, along with 6, 7, 8, whatsoever. I can actually just copy this thing. Also, I almost forgot. Where is got clean zeros? So at this point, we don't need these. We don't need to like track it anymore because we know we've fixed that. There we go, hit save. Come back over here. Now we're just gonna give these decimal points. One more. There we go. And then let's just copy this whole thing. Oh wait, let's go with a C out. Yep, there we go. A new extra end line right there. Hoop. There we go. Hoop. Go all the way down. We have that. There we go. Hoop. There we go. There we go. Alright, good. and then we just need to like give them negative signs. So okay. Give them negative signs to the first one. Okay, and then this one. Oh, there we go. There we go. And then lastly, we just need to like just copy this thing, paste it over here, and then give them all the final negatives. And just in case, if you still don't get it, these numbers are not interpreted as arithmetic data type. In this case, all of these inputs will be interpreted as strings. They will be calculated as strings. Yeah, let's see. Let's go with a cout. There we go. Paste. And then paste. There we go. Hit save. Now, let's give it a go and see if it's arithmetically correct. So let's compile this. Let's run it. Whoop. Whoa! What? Spectacular. Error. Why does it give us that? Let's just see. Why do we have error? So let's just hit clear. The first thing that we just have is error. But why? Where does it comes from? Let's see. First thing first, we definitely need to look at is multiplication safe. Okay. This, that, this, that. Okay. The first thing first, gonna look at is multiplication, which is this thing up here. Under what circumstances will it give error? Let's see. Clean zeros. Let's take a look at that. There we go. And then we just go with that. Let's just check what do we have at that moment. Okay, so far this step is correct. Next thing is to replace with all that stuff. Next thing is to remove the decimal point, which it did. Now check if any of the input strings are empty or just zeros. Huh. And this actually just gives them the string. Well, at this point, it should move on. So, if I just cut this thing out, I'll put this right here, and then I'll compile it. Okay. Okay, we have that. Good. Now, this. Now we can see. We can focus on step 4. In this case, over here, we can actually take a look at what is plate R at the moment. And plate R will not be corrected yet. Let's see. Huh. Interesting. It was working way long ago and now it's not. And just in case, this one can be changed to character set 0. So over here, I will just ask, okay, what is plate R? What is plate S? So, let me just paste it over here. Let me place it here. Plate S, and then S. There we go. And then over here, I'm gonna just say, okay. By the way, this thing is iterative, so I'm gonna just go with that. There we go. Whoop. Now let's see what does it says. Why plate R is like error. So there's something wrong with addition. Okay, I'm going to put a flag over here. Just to remind myself, hey, when I'm done, I'll come back here. So addition is odd in this case. So let's take a look. Addition. Under what circumstances it will give error? Let's see. Okay, at this point, let's just go with is debug true. Where is it? Oh, there we go. So I believe that is the addition stuff. So let's take a look at multiplication. There we go. We do not have any cout yet until we hit over here. Okay, and then we do the addition. So basically, right now we have this. but we only have the first 2 iterations and then gone kaput. Why it is so? Huh. I'm going to ask, did it hit here? Because if so, oh no, it hits here. From the looks of it, it should have like strip away the decimal point. Okay, I'll come back here, so I'll need to put a flag. Oh boy. But how did it ended up with that? Because take a look at this. Everything over here is in the character set. Fractal length. Where is it? Over here, I would just say this thing, and then I'll see what is plate S in the iteration. How? Let's save that again. New Pepe Oliver. Just in case, if you take a look at the title we have, I'm dealing with what I call string math, which is like when we are like coding stuff, we want to do like math arithmetic stuff. We just use int, float, long, doubles, all that stuff. When a number is small enough, we're good with it. The only problem becomes wonky is when you go with like numbers with too big. So string math over here is here to deal with that. Like it's here to deal with huge numbers and with huge precision. Now the problem I ran into is my addition was working and now it's not. So trying to fix that right now. Yep. Very big problem. So over here, plate S has been doing it correctly. But what if I just Control X, paste it here, remove this whole stuff, and then just do it again, just to see if it got corrupted or whatsoever. This is S2. So if we take a look at this, S2, okay, S2 seems pretty fine. So afterwards, R comes in, and then just okay. So at least we know that S is completely fine. Yes, I'm Extra Sharp Racer. Yes. And for the stream, I'm the host for the stream. But sometimes, like rarely, we take turns. But most of the time, like 99% of the time, it's me. But sometimes, like rarely, if we have some other teammates, then we'll just take turns or whatsoever. So yeah. Let's see. Yep. Hey, you read the description. That's good. Yep. Alright, let's see. So at least S is good, but R, not sure with R, so let's give that a go. And then at this point, R is, well, at the beginning R is like empty, I guess. Yeah, R is empty. So, and then let's see. Whoop. Alright, let's see, what do we have? R is empty. So now, basically, we're just asking, alright, we just want to add both of them together. What if both of them are empty? So now over here, plate A is 0, and then plate B. Huh. I wonder if we can split this. Yes, we can. Alright, good. So above here, so in A, in B, clean zeros, clean zeros. Plate R is empty. A becomes 0. Okay. Huh. Wait a second. Ooh, wait. Oh, my teacher wants us to make a calculator, but we never learned. Oh, calculator. We can actually go through that really quick after this. Like, when I'm done with this like string multiplication, we can actually do a really quick version of like calculator. But just in case, what programming language are you like using though, just in case? Let's see. You want us to use Python? Yuck! Python, why? Why Python? No. Why Python? I can only say Python is, to some extent, quite dangerous. Me personally, I prefer either JavaScript or C or C++ or C#. Python, I will explain it why afterwards. Remind me to do so. Remind me to explain why I hate Python. Alright, let's see. First thing first. Plate S is this, plate R is that. So, where is it? I think I lost it. Oh, over here. Plate R. So technically speaking, plate R is 0. Okay, yes, correct. And plate S is something with a decimal point. Okay. So over here, I would say, make sure both have decimal points. Oh, I sent that because you have to type everything. There's no autocorrect or auto recommend. Huh. Well, it's actually okay. Autocorrect or auto recommend is called IntelliSense. So if you have Visual Studio Code or Visual Studio, when you install it, okay, like for example, if you're dealing with Python or whatsoever, there should be, okay, like you go to extensions over here, and then once you go there, you just type IntelliSense, like IntelliSense, like so, like this one over here. There should be a whole bunch of like IntelliSense pop up, and then in your case, if you're using Python, maybe you can try typing Python IntelliSense. I don't know if Python have that, but probably it should have that, because in C++ we also have C++ IntelliSense, so we have that. Now, no, we have to make sure that both of them have decimal points. So, okay, if, okay, over here I'm going to say for dot string dot detect dot find character position. I'm going to say plate A, and then target, I'm looking for that, or in other words I should say character dot, yep, direction starting from the left. Then if I don't found any, meaning position is -1, then I know I need to give it 1. So plate A is character shorthand dot, wait, no, plate A plus that thing, and then we need to do the same thing for plate B as well. Where is it? Oh, there we go. Plate B, and then plate B. So you recommend C++? Well, I can only say C++ is my own personal favorite, but that does not exactly mean C++ is always superior. There are different reasons for you to use different programming languages. It's just, for me, I'm more used to C++, and C++ is more versatile for me to do crazier stuff. If you found out that you love Python and you find that Python is really good for you, feel free to stick with Python. If you love JavaScript, stick with it. Easy coding. Ooh, oh boy. It depends on what do you mean by easy at this point, though. Like, do you want to be like really easy at the hardware level, or do you want to be like really easy on the higher level? Because if you wanted to do something really easy at the hardware level, this means that if you want to do really high level stuff, it's hard. But if you really want to do like really easy stuff at the higher level, this means that you might not know what is happening under the hood, and then sometimes things can go not the way that you're expecting. So yeah, you don't want to have to do like 10 million words. Here's another thing. So let's just compare both the extreme ways. Let's just say there's this like one programming language that you only need to type a very short amount of words, and then there is this like one programming language that you need to type a lot of words. Let's first talk about the one that you need to type with a lot of words. So if you type a whole bunch of words, you know what you exactly want, and you can exactly predict or exactly like, you know, manipulate how things however you want, and you know exactly what will happen. The only sad thing is that's way too many stuff for you to type, and that's actually what you want to avoid, like that's actually what you want to avoid or something like that. Now if we go the other way, which is you need to just type just one simple word or whatsoever, and then the rest will be taken care of whatsoever. Now, yeah, fine, you can just type way lesser words or whatsoever. But two things. You will get limited but by what it can do for you. This is the first thing. Second thing is sometimes you think that you're predicting it will go this way, but you do not know what is under the hood of that little thing you typed, and because you think everything has been taken care by that little thing, but you do not really know how that little thing works under the hood. So sometimes it may gone wrong, and then you don't know how to do it. I just need to calculate that I can do basic math. Well, then it's just really easy. You just go plus, minus, star, slash, and then you're done. Yeah. I believe Python can do that as well. Okay, there we go. Hit save. Alright, time to compile this thing just to see if this thing is correct. Okay, progress. We're getting there. Plate R, this thing. Now, oh, progress always good. Yep, to some extent, yes. Let's see. So plate A, plate. Okay, and then now doing the math and all that stuff. Oh Lord. Okay, instead of like straight doing multiplication, let's take a step back and let's see how will it do addition. Not on the nuke. No, I'm not doing that. Okay. Like, oh boy, this is so weird now. This is so weird now. Let's see, 1, 2, 3, 4, 5 plus 6, 7, 8. The numbers are right, it's just the decimal points are terribly wrong. But why do we have that? Oh boy. Oh boy. Well, let's see. I wish I can like just push my terminal onto the right hand side instead of like sticking at the bottom. Can I? No? Ah. Nope, can't do that. Yeah, sort of. Move the extra zeros. Wait, where's the... Am I looking at... Oh, multiplication. Let's not look at that right now. Let's look at addition. Okay. Okay, let's see. That is clean zeros. And then over here is fraction length adjustments. Alright, there we go. Hit save. Compile. Let's see, what do we have? There we go. Just run. Okay. Fraction length adjustments. Okay, both of them are good. Now the first thing is, if both of them they have character dot, R will get the whatever it is. Let's see. Plate R will get the dot, and then A and B will lose the dot. So paste it over here. I'm going to call this thing dot strip. So plate A, plate B, and plate R. Save, and then compile, run, and then over here we have dot strip, and that takes care of it. Now Okay. Yeah, yeah. Okay. First iteration looks good. I'm going to call this thing a rift iteration. So let's compile this thing. Oh, premium show for free. Sure, start stripping. Oh, when I say stripping, I'm referring to like removing either the first or last character from a string. If you want the other type of stripping, you can go to somewhere else. Not here. We do not have that here. Alright, let's see. Just run. Alright, so over here we have... Yep, our iteration. Alright, good. 7 and 4, that's 11. I was expecting an 11. How did it get a 2 over there? Well, I guess it just gets a 2. Oh yeah, because yep, it's A, B, and CD. Oh, that's a 12. Well, okay, that explains it. GTA 5 shoe store in the middle. Huh? For that one, I don't quite get it. You need to give me the context in this case. You need to explain it. So over here, it just keeps on giving us the... Oh! Things starts to break over here. The strip and GT. Huh. Oh, okay. Let's see. Things start to break when so I'm going to assume that every time when we do that, every time when we're done with the arithmetic, A and B gets stripped. So now B is empty, which... Okay. B length is now equal to 0. So now goes out. Now, if there is any carries left, so okay, I'm going to say if is debug I'm going to say something like oh wait. Okay, plate A or plate B is now empty. So over here, just go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then over here, I'll just go. Let me just print out the stuff. So A and B over here. Whoop, there we go. So hit save. Let's see, what do we have? Compile. Whoop, there we go. Error iteration. There we go. This is now empty. 12. Huh. That's why. Okay. Okay. It's the way that we clean the zeros. Oh boy. So. So, technically speaking, oh boy. About how long you think this take? When you say this, do you mean string math or the thing that we have worked on today? This thing you worked on. Okay, so if you are referring to multiplication and multiplication save, zero cleaning, and then now addition, which is actually this entire stream, which is right now 6 hours something. If you are referring to the entire string math thingy, this thing, okay, this stream over here is the second episode, and if you go watch one of our VODs, oh boy, I cannot remember how long was it, but yeah, in that previous stream we made addition work, we also made subtraction work, so yeah. Let's see. Clean zeros. There we go. So this is the thing that we have. Decimal point giving. Hey. Crunching iteration. But Okay. For now, let's not deal with addition. Instead, we will go with 0 cleaning. Clean zeros. There we go. So in this case, let's just go 1, 2, 3, and let's see what it gave us. So total about 11. Probably. One, 2, 3 point. Interesting. Excuse me. Over here, I'm going to say step 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 4. Simplify. Last stream was about 4 hours and 40 minutes, I think. Huh. Okay. Okay, let's see. Most of the time, wait, let me check. What if we have 0, 0, 0? So let's have that. Yep, same result. Okay. Most of the time we have an int as an input, but we will have an extra decimal point at the end. So remove it. There we go. So let's see. Let's go with oh wait. So this means that if we get to have dot hashtag, then we get to demolish it. Yeah, let's do that. Over here I'm going to say string const dot hashtag. So dot hashtag, there we go. So it should be character shorthand dot plus character shorthand mechanism, the 0th one. There we go. Now just say int pause dot hashtag, which is the same thing over here. There we go. So we have that. If pause dot hashtag is not -1, meaning there exists such thing then I can say that thing should just literally vanish. So plate, looking for this, and then the replacement. Just vanish, boom. Yeah. So hit save. I'm going to boop. Run this thing. Huh. That did not work. Oh, that that explains it. There we go. There. Huh. It just removes the last one. Why is it so? Oh, also, let me just pause dot hashtag. Wait. There we go. -1. There we go. That should not happen. Let's see. If is debug, and cout. Plate. There we go. And just copy and paste the whole thing. Or wait, no. Yep, there we go. Or I should just crush this in a single line. Yep, there we go. Save or copy. So ever pasted it right here. Over here, I'm going to say before, and over here, I'm going to say after. There we go, and then over here, I'm going to say this. And then hit save. How did that? First a dot, then the hashtag. we go. So let's see. Well, it did remove that, and it did cap that. But how come it removed the last one? Huh. Oh. That explains it. But if we were to use this mechanism, what kind of strings we might end up with though? I guess pretty everything? Okay. I think it should be good. But if we were to have pause hashtag dot, because sometimes that can happen. So let's go with that. Copy and then paste. There we go. Hashtag dot. And then we'll just copy the same stuff. Hashtag dot. Cut this whole thing. And then just paste it right here. Plus. There we go. So this means that there we go. Position hashtag dot is -1. So in this case, it means that hashtag dot is not -1, then we can say we will give it a 0. So Control C, Control V, hashtag dot. We can replace it with a 0. So in this case, we need a character shorthand set 0 plus character shorthand dot. So I'm just going to type it over here, or you know what, I'm going to send it back and write it as a single line code, because this thing is long enough and good enough to be written in a single line. Right here. There we go. Whoop. There we go. Hey. Over here I'm just going to make little notes. Turning -0 into something which is just negative sign. Over here, this one, it turns #0 into 0. Over here, it turns 0 hashtag into hashtag. But this one I got it wrong. It also turns it into a hashtag as well. There we go. For this one is DH. Dot hashtag. Dot hashtag. It just turns into like, okay, let's just say vanish. This one is hashtag dot. Which is 0 dot. There you go. Let's hit save. Okay, we still have the same problem. Yeah, I just removed the last one. So I would say at this point we don't need this. But if we have negative dot, ooh. Okay, let's see. Negative dot. Can we have dot negative? No. Okay. So we have 1, and then we'll have this one. Alright. Okay, so just copy this and paste this. This is now negative dot. So there we have that. And then if pause negative dot is not found, then we're done. Sort of. We'll see. negative dot. So negative dot, it's basically just negative 0 dot. Basically just becomes 0 dot. So, which is actually the same as this one though. Excuse me. So I might just like copy this thing and then paste it right here, and then this one is negative dot. If that's the case, negative dot DH HD ND. There we go. Yep. And then yep. Hit save, recompile, and then see what do we have. Oh! Okay. Over here I'm going to say there might be leftover hashtags. So I'm just gonna say if plate.at 0 is character mechanism. If it's that thing, then I'm going to say plate. Oh yeah, I'm going to like strip it. So I'm going to say number. Strip it. In this case, it should be plate, and take off the head. There we go. So that's the hashtag. So, over here, I'm going to say number. Yeah, whatever. I'm going to say plate dot at 0. And why would it don't want that? Oh, that's a string. Oh. Okay, got it. Character mechanism 0. And then yep. Whoop. Whoop. And then we can also say this thing plate dot at plate dot length -1. Character mechanism 0. There we go. And then we'll just say number strip, and then let's go with plate. Let's go with tails, and then we're good. There we go, and then whoop, press this, and then there we go. Perfect. So we finally converted this to that. Okay, now time to test the clean zeros again. Let's see. Go, and then I'm just gonna go with like really wonky stuff. Let's see, what will it give us? So now let's just say I don't want to debug it. Ooh. Oh no. Excuse me. See, this is a perfect example just to say I'm using something like way too high level, and I thought it will work, but turns out no, it breaks. So this is a perfect example just to say that. Terminate a call after throwing an instance, this out of range. Huh. So it breaks when it's all zeros. Alright, let's see what happens. Or let's just do this again, but this time we're gonna debug it. And this time we know that this works. So we can actually just, there we go. Save, and then whoop. Alright, let's see. Okay. I think we got this. Oh, okay. Okay, I see. Okay, let's see. There could be two hashtags. There could be one hashtag. So we need to know what's the situation. So right, for this example over here, now we only have exactly just one hashtag. So we need to like able to recognize that. So just say if plate is character mechanism nope 0 plus another character shorthand mechanism also a 0. If this is the case, then we can just simply return that, okay, this is a perfect 0, nothing much else. Or this just gives us a single just a single hashtag. It's also 0 as well. Could there be hashtag minus? We don't know, never tried that before. Well, let's take a look at that. So, let's cut this thing. Let's paste it here. Let's do copy and paste. Plate is this return 0. Or I can say plate is a single hashtag return 0. There we go. So like the end over here. Oh boy, that's a totally different situation. What? Ooh. Oh, I have those stuff. Okay, let's see. So over here we have this And then when it becomes this, we have this plate is that. So just give us 0. Same thing over here. Get crunch down, crunch down, crunch, 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 down to a single hashtag. And all of them did manage to give us 0. But what if now I give them negative sign? So let's just run. Excuse me. That gives us a 0, gives us a 0. Oh lord, a lot of missing parts. Alright, let's see. Okay. Yeah. Okay, okay, okay. So it just gives us a negative sign. Okay. So one possible situation is we have that. Just hashtag negative sign. Huh. Hashtag and then negative sign. So there we go. Return 0. There we go. So we just do that. Go. Is that give us 0? Alright, good. That demolishes. Squish, squish, squish. Now left with that. Now it's this. Give us that. Okay, good. That one's gone. That one's got squished. And then now we have that. So this thing over here. Okay. Got squished. Okay. Okay. So that one got that. That one got this, and then we got from this to whatever this is. Is this return? Huh. Let's see. Alright, this one is over here, so we just return this. Oh, at this point, we just say that. Yeah, turn 0, and then whatever it is. There we go. And at this point, we do not need that. We do not need that. Because we know it will return 0 no matter what. we go. Hit that. Also, I'm going to say whoop. ENDL, there we go. Alright, let's hit save. And let's do that. There we go. So let's take a look. There we go. Receive that. No, is that? No, is that? Crunch it down. There we go. Return that. Okay. Cool. This thing. Also return that. Cool. Also return that. And finally also return that. And also return that. Okay, cool. So we're testing this. Alright, let's see what do we have. So received 1, 2, 3. In the end it's just 1, 2, 3. Alright, good. Received 1, 2, 3.0. Also expecting 1, 2, 3, good. 0.456, yeah. 0.456, yeah. Same thing. Yep, there we go. Same thing. Yeah, okay, good. Yeah, same thing. Okay, good. Now we have these. So the first 3 and the last 3 will be gone. First 3, last 3, gone. Alright, good. What about if they are now negative? So gonna hit save right now. Give it a test. So we were to just before compile it. There we go. Negative 1, 2, 3 is now negative 1, 2, 3. Good. Negative 1, 2, 3 should be still negative 1, 2, 3. Good. Negative 0.456. 0.456. Oh no. Negative sign is gone. Okay. We'll come back to that. 0.456. There we go. Negative 1, 2, 3, 4, 5, 6. Returns. Okay. Receive this. Give us that. Okay, good. Receive this. Give us that. Okay. Receive this. Okay, that looks pretty good. So this is the only problem. Negative 0 point something. Negative 0 point something. Why did it not work? Let's see. First we have this. do we have? Excuse me. First thing first, let's see. Do we have -0? No. Do we have #0? No. 0 hashtag? No. Dot hashtag? No. Hashtag dot? No. Minus dot? Then yes, it becomes a 0. Oh! That might not be the case, so I cannot just literally say that. Huh. I'm going to change the rule a little bit. Instead of just that, I'm going to say, if this happens, then we know it means that. So we can definitely say it's 0, huh? If we have like something like this, Okay, negative dot hashtag. Negative dot hashtag. Negative dot hashtag. Plus character mechanism. Pick the 0th one. There we go. Oh, there we go. You me. Go, and then alright, this one works fine. This one works fine. Nope. That one, and this one. So let's go with that. Okay, that does not exactly look that good. I would say the moment when we see hashtag -0 point, then we know, okay, we cannot do anything much, so we'll just leave it there. So coming back over here, let's make a new string, which is, oh boy, string const hashtag -0 dot. Oh boy, that is so weird. First, it's the hashtag. And then the negative sign. Excuse me. After the negative sign, it's the character 0. There we go. And then it's the dot. So character shorthand dot. And then there we go. So let's go with int pause hashtag -0 dot. Doing the same thing, just in this case we have hashtag -0 dot. Then if we just this pause hn0d is -1. So let's see. Hashtag -0 dot will actually just become -0 dot, knowing, oh, we're done with the head in this case. So Control C, Control V. So so if hashtag -0d is not 1, meaning we're just gonna find it in this case. Hashtag -0d, or there we go. In this case, we're just gonna replace it with the negative sign. Character shorthand negative sign plus the 0 and the dot. Okay, and because okay, you know what? I'm going to put this at the front. Or we can look for hashtag 0 dot. Then we know we're done. 0 dot. So we can have that. So let's see. Hashtag 0 dot. Let's see. Just copy this whole thing. Paste it. Hashtag 0 dot. So hashtag no negative sign this time. And then just that. Paste it over here. Excuse me. There we go. then we'll just copy and paste this whole thing. There we go. This time no negative sign. So if we see that, then we know it's just 0 point something. We don't need a hashtag at the front. So we'll just replace it with that. There we go. Four, three. There we go. Cut it. Ace it.
Recursion isn't real. Assembly can't do recursion.
Oh, we do not have that yet?
Exactly.
Okay. So if that's the case, let's just go Control C. Paste it over here. And then we'll just do that. Let's cut this thing, paste it over here. Over here. Cut this thing, paste it over here. And there we go. So we have that. Where is it? So, okay. Something is actually 0 point something. Like this one over here might not exactly be the case. So negative point something is negative 0 point something. Oh wait, if it hits, oh okay. So here just means that we have that. Okay, over here just gonna be character 0 with no dot. Okay, let's hit save. Alright, let's see what will it give us right now. Oh boy. Huh. It didn't catch that. Hashtag minus 0 dot. Okay, fine, let's do it this way. Else, if this thing. So else if this, paste it over here, so we have that. Else, this is me. I'm going to like cut this thing, paste it over here. There we go. We have that. Cut that, paste it. There we go. We have a little bit of like refactor to do. There we go. Here. Cut it, paste it. And then over here we can just say else if this thing yeah. Let's remove that. And then let's just cut this thing, paste it over here. There we go. There we go. Wait, why do... Huh. There we go, there we go. That's a bit odd. And we have that there. There we go. And then I'll just go with... cut. Paste. And then we'll just have... oh, no. There we go. Else if this thing, that thing, this thing. There we go. Yep, there we go. Else this thing will be over here, and this thing will be over here, and then there we go. There we go. This thing over here, and then finally, if we have this, there we go, right there, there we go, and then finally this thing. Uh-oh, there we go. Alright, and then we're good with that. Excuse me. Alright, so let's see how it's like being processed, because it did not catch that. Oh, now it catches. negative 0 point, huh? Interesting. So I guess maybe this is a part of the processing, like the post-processing part. Okay, over here we're just gonna say remove hashtags. Over here we can say hashtag removal or whatsoever, but we're just gonna say that. Over here I'm just gonna say we got negative 0.456. Sometimes we will have the situation mentioned above. So we need to deal with that. So if for string detect contain plate if it contains negative, so character shorthand negative, and then character shorthand dot. If this thing happens, like if it's not -1, meaning if it happens, then we know that plate will become for what in the world is that? Yeah, fine, whatever. Plate for. Also, before that, let me quickly do this. Whoop. And once again, if you read the descriptions, you can definitely know promotions or advertisements of any kind is prohibited. So, without further ado, there we go. There we go. Now we just need to replace the string. So it's another string. Manip. Replace. There we go. Replace the string, which is mentioned above, which is this one. Oh yeah, starting from the left. Do we need anything? Target. There we go. And then the target. And then change it to, what should I change it to? Like add a 0 in between them. Excuse me. Character set 0. So this will turn the point something into something like negative 0.123. There we go. There we go. Okay, hit save. Alright, compile. And then just run. There we go. So now we have that. Okay. So from the looks of it, it's pretty good now, I suppose. So let's check all of them again just to see if it works. There we go. Hit save. Compile. And then for now, I'm just gonna say debug is now false. So negative 123, negative 123, negative 0.456, negative 123, 456. Okay. Okay, looking good. Okay, and then the rest are just a whole bunch of zeros. Okay, pretty good. So now, since we have all of these done, now we can get back to addition. Huh. There we go, and it finally starts working again. I guess. Yeah, okay, good. So if this thing works now, then I'm going to assume that multiplication is also safe to do now. Oh. Huh. Not that case. Alright, so... Wait. Let me hit save, copy, and just paste it all over the place. And then let's go with decimals. And then just throw this thing out. For this one, I just go. There we go. And then just paste it. Paste it. Over here. There we go. Whoop. Smack it right there. And then we'll just do it one final time. Let's do it right here. So over here we have that. Okay, I'm going to do some checking on my phone just to see if I got it right. Okay. Okay, there we go. Okay, good. Let me see. 12.5. Okay, good. There we go. Okay, so it seems like addition is fine right now. So I'm just gonna like, for now I'm just going to like comment out this huge block. Now we just need to like figure it out multiplication. But as you can see a while ago, the moment that we just simply test multiplication, it just goes out of range. So let's see what's wrong. So at least now we can just say, okay, for now we think clean zeros is good. Now addition is also good. Now let's look into multiplication. So in this case, let's just hit clear and just recompile what we have so far and then run it. So over here we have plate S, plate R, whatsoever, and then it just goes out of range. But where exactly getting out of range? Well, I believe over here. basic string at this, which is 0. Okay. In addition, do we have anything that deals with getting the length of something? Let's see. Okay, so here we got it. Oh wait. So, okay, I think I know what's the problem now. Plate R should be starting from 0. So, excuse me. Okay, let's see. There we go. Huh. Still. I thought, wait a second. Okay. Over here we have, okay. Now let's set to true. So, go here. So, let's take a look. Hey. Plate R. Strange. Plate R. Whoop, whoop. Plate R. DL. There we go. By the way, where is the flag? Still have that thing over there. Huh. Let's try to find this. Oh. Oh, okay. Okay, let's take a look. What is this thing? This is multiplication. Over here I can say if is debug. I can say cout over here. Oh boy, what can we type? Wait a second. Why? Addition over here. Okay. just go with this, and then here we will say 1 2 3 4 1 2 3 4 1 2 3 4 1 2 3 4. Addition start. And then when it ends, so that's the addition part. Now the multiplication part. I remember that we were dealing with this. Okay, fine. So over here, I'm just going to say, whoop, bam, over here. Over here, I'm going to say multiplication start. And then clean zeros. Alright, now just to make things clear. So number clean zeros. Over here, I'll say, okay. I'll post this thing over here. And then over here, I'll say clean zero start. And then this one will go over here as well. There we go. And then copy this thing, and when I reach the end, and then I will say clean zero end. There we go. So let's see. Debug. Okay. So over here we have plate S. Plate S. So okay. Over here I will just say if debug. If is debug, then I'll just do cout zero cleaning. And then over here, I'll just literally say, plate A is now this thing. Plate B is now this thing. do the same thing again. Remove decimal point. Ah, that might not be the case over here. So over here I will just say character shorthand dot. Alright. Copy this thing. Okay. No. Okay. Excuse me. Time table start. There we go. So we have that. And then now we can just remove that. There we go. Let's see. I will also say I'm gonna get these as well. There we go. Excuse me. Plate S will be that. Here, just smack it with this R. There we go. So at least now we can track what layer we are in. Oh, come on. Multiplication start, clean 0 start, clean 0 n, clean 0 start, clean 0 n. 0 cleaning, that's the result of it. Remove decimal point, timetable start, this thing. Addition start. Oh. Strange. Okay, so for some weird reason, hashtag dot hashtag is a possible situation. So we need to go back to zero cleaning. Where is it? Oh, there it is. Let's see where it is. Alright, let's see. Over here, I'm going to say, I'm just going to like copy this thing. Whoop. And then say hashtag dot hashtag. So I'm gonna just copy this whole thing and just paste it right here, because apparently it's a thing over here and that does not make sense. So yeah, just copy this whole thing, smack it right here, hashtag dot hashtag, position hashtag dot hashtag is -1. Else, let's check. So it should be somewhere else here. So Control C, Control V, hashtag dot hashtag. Now apparently this just means it should become 0. Like straight up 0. And then once you're 0, you have to get out of the loop, and then you're done. Okay, this one will be a safety switch, and then I can say if plate dot length is not 0, which means it's bigger than 0. Like it could be 1, it could be more than 1. Or wait, no, it must be more than 1. If it equals to 1, then let's say we only have a single hashtag. We did end up with a single hashtag, but if we only end up with a single if we only ended up with a single number, let's say 1 or whatever, right? If this thing is a hashtag, no. If this thing length is 1, okay. If this thing is a hashtag, no, then do nothing. Okay. So let's save. And then I would say that would be done for our 0 cleaning. Let's hit save. And then let's compile it. Back to multiplication. Huh. Let's take a look. Interesting. Okay, let me hit clear again, and then just run it again. And then let's see, what do we have as a whole? First multiplication start, clean 0 start. This will give us that. Alright. This one will just give us that. Alright, good. 0 cleaning. In the end, we get this. So that's good. Remove the decimal point. In the end, we get that. Alright. Timetable start. We have this, we have this, we have that. Alright. We have this. Addition start. Clean 0. We got this. So in the end we got 0. We have this. In the end we have that. Alright, good. So in the end we have that. Good. Fraction length adjustment. Dot strip. Okay, cool. Arif iteration. Okay, I wonder if we got it right though. So, if we go back to the test, our test is to see if we multiply these two numbers together. So, 1, 2, 3, 4, 5, multiply by 6, 7, 8. And yes, it's correct. Now, let's see. So, if that is correct, now we can test the rest of these and then see if they are correct. So, at this point, there are way too many test cases. So let's just switch to this debug is false. Multiplication. Whoop. Now we can test all of these. Let's hit save. This is going to be a huge pile. Let's hit clear. And then let's go with compile. And then let's just say run. Huh. Okay. Like, I do not have my webcam on, but my mouse is like way wide right now. So if we just simply just take where is it? Boop, there we go. So if I clear that and then I just go 1, 2, 3, 4, 5 multiply by 6, 7, 8, the blob I will always get is 83691 and then the 0 at the end. So this one over here. Okay, so every time I go downwards, decimal will just keep on going up, and starting from over here, decimal keeps on going up. Okay, starting from over here, okay, decimal keep on going up. Okay, good. And then the negative kicks in. This one is also negatives, kicks in. And then back to positive again. There we go. Oh, Now, just want to like make sure. So, cut it. Paste it. There we go. So, excuse me. So back to this one. I just want to like make sure that 0.000 that thing will work with this. So okay, cool. So how many decimal points do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 decimal points minus 3. We should have 5. Right? Wait, wait, no, wait, wait. So technically speaking, this should be gone. It was just that. And then this one over here, we have this. So 8 and then 3. Wait, what? Oh, okay. 1, 2, 3, and then multiply by 6, 7, 8. 1, 2, 3. It did not work with really like wonky situations like this one, so let's see. There we go. The first one is wrong, the second one is correct. So I would like to see how is zero cleaning done. So I would like to see how zero cleaning is done on that one. So let's comment these two out, and then let's just paste it over here. Paste it over here, and then come back over here. I'm going to say true again, just to see how do we clean that specific zero. So over here we have, oh, everything's right. Huh. Yeah, that looks right. Then how come that is wrong? Multiplication safe. Fine, let's see what do we have there. Is pause, is neck, get apps. And then afterwards, I wonder. Okay, let's take a look at this. So we have this. I'm just going to like copy this thing, paste it over here, and I just go with this. For now, this one over here, let's go with a false. Compile it. Both of them end up with the same wrong answer. However, the moment when I start removing the extra zeros, it starts giving up the correct answer. So that's actually pretty weird, because both of these, they undergo the same cleaning zero procedure. Like, I can just like put it over here. Like, this is what we have. And then we just copy and paste this thing again. Now you can see, no matter if it's that or that, it gives you the same result. But the first one is wrong, and then the last two is correct. Let's see. How many versions of cleaning zeros do we have? Number of clean zeros, we only have one. Wait. Fractal length, including trailing zero. Yeah, no. Okay. Alright, over here I'm just going to like put it right here. Okay. Variable prepare. So over here we have plate A, we have plate B, and then we have frac length A, and then over here we have frac length B, and then over here we have true frag length A, ENDL, true frag length B, ENDL. There we go. So, okay, clean zeros. Okay, let's hit save. Let's come back over here. Let's not focus on that one. Let's focus on this one. And I forgot, we need this thing over here. True. Compile it. Then boom. So let's take a look how it's done. What in the world? Okay, let's see. Clear. And then let's just say just run. There we go. And then to the very top, oh boy, we can't even see it. Oh no. But from the looks of it, we know it's a whole bunch of 0. So, huh. Oh boy, this is like weird. Hmm. Hmm. Okay, let's start with a simpler number. Let's copy that. Compile it, and then we will run it and then see what it gives us. So the correct answer would have been, let's see, excuse me, 8.04, but over here we have 8040. So, do we have the beginning? Oh, yep, yes, we have that. Alright, cool. So, let's see. Variable prepare. We have that. Plate A, plate B. Okay. Okay, good. Frac length for A, frac length for B. Yeah, good. Clean 0. So at the end, we will have 0.012. Okay, yeah, good. What about this? 670. This will give us that. Yeah, no problem. Oh. Oh. This thing becomes sus now. So the moment it start removing decimal point. Huh. Oh. The place where it starts removing decimal points is sus. Let's take a look at that. Removing decimal point. So, okay. Over here. That explains it. There we go. So, if we start, come down over here, just do a clear, compile, run. So there goes our correct answer, 8.04. So if we come back over here, now we will do our comparison in between this and that, which is the optimized version of it. Hit save, and then let's just do that. And then over here it will just do false. Hit save, and then recompile it again. We just want to see if the result is correct in this case. Whoop. Hey, just like make sure. So let's go with 0.000123455 multiply by 678 and then 000 83.6991. Perfect, which is exactly what we have here. Oh, finally. Oh, my neck is hurting. There we go. Okay, so according to our original plan is we need multiplication, we need division, we need modulation. After 8 hours, we only have multiplication done. But I have a strong feeling that because division is actually based on subtraction and multiplication, I have a strong feeling that we can actually quickly finish this whole thing. So, okay, I'm going to see if I can work with division. So, let's give it a go. String. Let's go with int A. String in B. So we might want decimal point. So our first question is, how do we divide things? Let's just focusing on dividing just integers, because we can also use the same trick to we just factor out every decimal point we have, and then afterwards we just put it together. So let's see. Alright, so we are going to assume that we are dividing this upper string by this lower string over here. So, okay. Oh, also we need to know when do we stop, because sometimes we just get ourselves into infinite decimal loop. So we will say decimal precision. Okay, let's see. first thing that I can take a look at is... Oh wait, do we still have Microsoft Paint? Oh yes, we do. Alright, let's do it this way. So, let's pull this thing out. So, assume that we have this, whatever we have. And then our smaller number is this one. And then our answer will be written in R, red dot whatsoever, right? So first thing that I'll definitely do is just look at this. So in other words, it's almost something like slipping over to this side and then see, hey, if this is divisible by this, but apparently no. So do the same thing again. Until when this is bigger enough to get divided by this. But I'm going to say, okay, it's gonna be a minus. So every time we do a subtraction, I have a counter. So let's just say our counter right over here, let's say it's 0. Every time I do a subtraction, this will get decreased. Every time I do that, I increase by 1. Every time I do that, I increase by 1. Until such that this is small enough. When this becomes small enough, I just pull in the next one and then I output the number I have, and then I start from 0 again. Okay, so now we have this in our mind. Alright, let's see if we can code this thing. Okay, here I'm going to say assume that we have the following setup and variables. The string to be divided is this. The string to divide a plate string, we call it a left. Another plate string, a right. Plate string. Let's call this thing R. For our final answer. And then over here, let's have a counter. For our current indexed guess. So in this case, we're just gonna say over here I'm just gonna say main concept. Over here I'm just gonna say file. I'm just gonna say toggle line comment and cut everything, paste over here. Alright, so I'm just gonna say so far we have the following. So in this case you will have string plate al, which is going to be empty, string plate ar, which is gonna get initialized to that. Okay, and then we have string plate b in b, there we go. And then string r or plate r is gonna be an empty string, and then we're gonna have a counter. Okay, int c. Starting at 0. Okay, so let's see. First we're gonna ask the question. Now we can say now begin. One is plate al big enough to be divided by plate b. If it's yes, and then no. Okay, let's say assume it's a no. Okay, then we're gonna say pull the leftmost digit from plate A right to plate A left, and then go to step 1, which is this one over here. Keep on doing the same thing until it says yes. Okay, then go to step 2. So what is step 2? Which is, okay, we're gonna say right now plate AL is big enough to be subtracted by plate B. Oh, so it's not divided but subtracted. Okay. So this means that every time, okay, so So we're gonna say plate B is, wait, no. Plate A left is plate A left minus plate B. And at the same time, we're gonna do counter plus plus. There we go. So we have counter plus plus. And then now we ask the question, oh wait. So wait, because it feels like now we are just asking this though. Because whenever it becomes way too small, then it pulls another one and then export the counter. Let's see. Interesting. Counter plus plus. And I would just say go to step 3. And basically step 3 and step 1 is quite similar. Just to see, hey, if this is still big enough to get subtracted by B. If yes, go to step 2 again and again and again and again until it becomes small enough. Then we pull the same thing again. However, we say export counter to plate R. And then counter equals 0. And then go to step 2. But there is also one situation where we can just stop happily. Which is the moment when the subtracted stuff becomes 0. Oh wait, is it? Okay, let's do some more experiments. So let's see. Assume that I'm gonna pick 1, 3, 4, 8, 5. And then I'm going to say divide by 7. So we know 7 Oh wait. Okay. Let's just take this thing and then we will simulate it by using our computer science way. Let's see. Typically saying this is actually 0. So, okay, I'm going to see if afterwards. Okay, so we can find any similarity in between. So 1, 3, 4, 8, 5, 7. The true proper way is we start from 0, 1, and 3. So that's 1, 7, 6, and then 4, 5, 8, 5, 9. Oh, that will do it. No, 7, 9. 1, 8. And then the 2. 7, 2, that's 14. 45. 6, so that's a 42. And then we left with a 3. And then 3 starts all over again, so it's, yeah. It's gonna be 0.34853485, something like that, I assume. Let's see. 13485 divided by 7. No, it's even more than that. But yeah. We'll see. Okay. So, if we were to use our computer science method, what we have is 1, 3, 4, 8, 5. And then we have 7. And then we have starting with 0. This is our counter, but we still have our string. So let's go with first. First, the question that we ask is, we pull in a number and ask, hey, if this is good enough to get subtracted. The answer is no, because I was like, because the main idea I'm having over here is every time when you pull it, you output what is on the counter. Let's assume that that is true. I pull this one over here, so now I output a 0, which is this one over here, I assume. Next, I ask, okay, because I just pull it, I export. Do it again. I pull it. Wait, is it? Wait. Oh boy. Iterative stuff is a little bit hard to track off. Get tracked by humans in this case. Let's see. Okay, assume it's not starting at step 1, instead it's starting at step 3. So right now I can just simply ask if this thing is bigger than, like, big enough for like plate B. If yes, then go on. Otherwise, pull, export, reset. And then maybe go to 3 instead. Yeah, that looks better. So you know what? I'm going to take a screenshot. And then gonna paste it over here. Okay, so we have that. So let's say we start from here. Okay, is this big enough to be subtracted by plate B? No. So pull the leftmost digit from this. Pull it. Export it, which we did. Counter to 0. Okay. And then again. Now, is it big enough? No. So we pull it again. And then we export it. Export it. Counter is now 0. Now go to step 3, which is this thing again. Now, is this thing big enough? The answer is yes. So go to step 2. Okay, so right now this thing is big enough to be subtracted by plate B, which is this thing. Like, this thing is plate A left. This is plate B. So 13 will now become 6. And every time I do that, counter goes up by 1. Now, go to step 3. Okay, is this thing big enough to be subtracted by plate B? No, not anymore. If so, pull it. Every time we pull it, export it, and then counter is now 0. And then do it again. And now basically we're now over here now. So is 7, can 7 subtract that? So I'm going to like cheat a little bit. I'm just going to say, after I do this 9 times. So after 9 times, this will become 9. After I do it 9 times, this will become 1, which is actually this thing over here. And then when it's not big enough, I'm going to pull it, and when I pull it, I export it, and then counter is 0. So let's get this thing back. Counter is 0. Okay, good. And then go to step 3 again. Is it big enough? Yes. I'm going to cheat. I'm going to do it twice. So when I do it twice, 0 will become 2. 18 will become 4. And then when I come back here, I'm gonna say, alright, it's not big enough to get subtracted, so we are going to export 2, and then counter sets to 0, and then go to step 3 again. Oh wait, I forgot to pull it. Yeah, forgot to pull it. So that's how we get 45. And then, oh, we also need to like figure it out. Are they enough things to get pulled though? So you can see. So technically speaking, we can actually just use this as our beginning. So whoop, whoop. But now we need to like make sure, hey, can we really pull it? So, So I'm just gonna say let's see, if we can, okay, or let's just say if there are digits to get pulled. So technically speaking, over here, yeah, and then I'm just gonna say now update this to the following, which is actually just copy and paste, and then just simply ask if no, we can just ask, are there any digits to be pulled from plate right or AR to plate A left? And then the answer can be once again yes or no. So if the answer is yes, then it will just simply just pull it. Else, if no, then this means that we have already reached the decimal point. So the thing that you can only keep on pulling is actually the zeros. So in this case, export decimal point to plate R, pull a 0 instead. And then every time you do this, no matter it is successful or not, you always go counter set to 0, and then you say go to step 1 again. And then I would say this one over here. Oh wait, export this to plate R. If okay, over here I would say only if plate R do not have a decimal point yet. Pull a 0 to plate AL. And then rinse and repeat until when we're good enough with the precision we have. So let's see. Counter. Wait, before that, I forgot it. We need to like export the counter to plate R. Also, we can like check have we reached our what was it? Desired precision? Either fract length for plate R is long enough. If the answer is yes, we are done. If no, and then we just do that. So basically, step 2. Oh, So basically we can just say step 2 is actually just this huge thing, so just and then just this and then go back. So we just go this and then we'll go that, and then we're good. So there we have it. But I would say, now can be converted into code. So I can just say we need another extra boolean just to say job done. Oh, there we go. Before that, let me close this thing off. Oh, Nemo, welcome back, Pepe. I didn't saw you there because I covered my other screen with Microsoft Paint while I was doing my draft. But yes, now we are finally doing division right now. So, yay! At least now multiplication works with both int, float, positive, and negative as well. So, that's good. Alright. Job done. There we go. Job done. Let's set this thing to false. And then we're just gonna say while job done is false. We're just gonna keep on doing this whole thing. So let's just like copy this whole thing and then paste it over here. Now, yeah. So I would say once this whole thing is done, I will export this whole thing onto our team's website and everyone can actually download it and use it as well. Just remember to, like, you know, in the footnotes, just put the original link. So yeah, you know, plagiarism is not that good after all. So let's see. So we have that. So in this case, basically we are asking if plate AO is big enough to be subtracted by this. If so, we're just gonna like put this thing right here. Hope. Otherwise, no. There we go. There we go. Let's see. Borrow from the next digit. But first, we are just gonna ask if are there any digits to be pulled off from AR to AL. the answer can be both yes or no. So this thing get cut, put it over here, no, get cut, oh, there we go, paste it over here. So afterwards we will export it, counter set to 0. Have we reached our position? So if just gonna say, have we reached our position? And then the answer can be yes and no. So cut this thing, paste it here, and then over here we're gonna say else whatever, then crop it, paste it. So the moment when we say we are done, we can say job done is true. There we go. So we have that. Or otherwise, go back to step 1. Or this means that, yeah, start all over again. Or basically just boop, we don't need that. So basically if it says no, just gonna ask again, hey, is if this thing is big enough to get subtracted by that. Alright, from the looks of it, this looks pretty good. So now let's do it in code. So now let's go with string plate a left. For now it's nothing. Over here we have string plate a right. For now it's in a. Over here string we have plate b, which is in b, and then string we have plate r. For now it's nothing, and then also we need an int. We have the counter starts at 0. Okay, so now we have that. Now let's just copy this whole thing and then just paste this thing down over here, and it's going to have a whole bunch of syntax error because these are actually all pseudocode. There we go. Now let's see. Big enough to be subtracted by this. So in other words, it's basically asking number compare. Let's go with ABS. Like for now, we're just gonna make sure we're dealing with like positive numbers, because soon afterwards, just like multiplication, we can just like take care of like it's either positive or negative easily. So now we're just gonna like make sure that plate AL and compared to plate B, this will give us a string if A is bigger than B. Or at some point, we're just gonna say if this thing compared ABS plate AL or plate B could give us A equals B. There we go. So it could happen, right? Here we go. So you're gonna say, yes, right now, this is gonna happen. This is gonna happen. So basically, this one translates to plate AL is actually subtraction. And then plate AL and then plate B. So this translates to that. And then for every time you do that, counter plus plus. Otherwise, we're gonna like start borrowing it from the next digit. Okay, so are there any digits to be pulled from that? So in this case, this is actually asking if plate AR dot length is bigger than 0. If so, then we can say I'm going to say char temp pull, or I can do it the easier way. I can do plate AL is plate AL plus plate AR dot at 0. And then this also means that plate AR will be forward dot string dot manip dot trim safe. Plate or wait, I have a better idea. So this will be number and then strip again. This time it's going to be plate AR, and this time it's the head. So we have that. So there we go. We have that. We have that. Else, it's gonna do this. So over here, we're just gonna say, okay, at this point, okay, we're just gonna export this thing, but only if plate R do not have decimal point. So we're just gonna ask if forward dot string dot detect find character position among the string plate R character target, which is character dot the direction. Let's start from the left. If this thing were to be -1, meaning nowhere to be found, meaning if it does not have a dot. I wanna be a test dummy on string math webs. add a Pepe feature. Whoa, what? Why? A Pepe? No. How is Pepe has anything to do with math? I don't get it. Oh boy. But yeah. Wanna be a test dummy? Ooh, that would be good. But if you're able to generate a test file, or maybe make a blog post of it, or maybe something like make a Twitter post or an Instagram post or a Blue Sky post or whatsoever talking about this, and then you do all the tests and everything pass or something fail, you report it. I'll definitely take a look at it. Yeah. Alright, let's see. If this thing has no decimal point, then we can say plate R will be plate R plus decimal point. I can send it DC if it fail. Oh, well, that also works as well. Yeah, cool. Like, you can actually like send it on the computer science channel where, you know. Yep. Let's see. Decimal point. So it's actually character dot. Or let's just say shorthand dot. There we go. I don't want like any weird stuff going on. So we have that. And then no matter if we put a dot or not already, and then we're just gonna put a 0. And oh, there you are. Just in case. How come your Discord ID is a big string of number? Anyway, I'm gonna just where is it? Is it this one? There we go. I must say hi. There we go. So yeah, if you have any computer science related problem like programming and all that stuff, let's see where to post it. Yep, there we go. Boop, boop. There we go. So that's where you post it. Alright, let's see. Now, pull a 0 to plate. So at this point, we're just gonna say plate AL is plate AL plus character shorthand set 0. So there we go. When this thing is done, export counter to plate R. Oh, okay, so this basically means character set, or now I just want to do this the safe way. So let's do. Oh wait, can we do character set? Oh yes, we can. Character set. In this case, we're just gonna do counter. This will give us the character representing that number, and then when we export it, yeah, we attached it on the right hand side. So we can say plate R is plate R plus whatever this is, and then that thing's gone, and then counter resets to 0. Now we can say if we have reached our desired position. So let's see. Let's do number frag length. Frag length. Let's see. Oh, let's just say if it fails, we'll send a video of it. Oh, cool. Okay. Yeah, let's go. Number frag length. If plate R. Do we need trailing zeros? Okay, I'll say yes. For plate R is long enough. Okay, so if this thing is bigger or equal to the in desired position, if yes, we are done. So job done is now true. Otherwise, start all over again whatsoever. And then the moment when we are done, let's just return plate R and see what do we have. So this is going to be a weird one, and to be honest, I'm not expecting it to like work, but let's see what do we have. So according to our experiment a while ago, if we take 13485 divided by 7, we will get 1926 or something like that. Oh, when you're finished, I will spend 30 minutes testing the website. Well, okay, first thing first. This is written in C++, and C++ will not exactly always run on a website. The way that you set this thing up is to set up a C++ environment. So there are a few things that you need to like set up first. The first thing first is you need a terminal, but I believe a terminal is built in for every machine. The second thing you need is a compiler. In this case, I use G++, but depends on your situation, you may need different compilers. Some people use GCC, some people use G++ whatsoever. So yeah, you have to set up that way. Okay, so let's give it a test. Multiplication, like, okay, just to demonstrate what string math can do so far is you see this whole bunch of like multiplication, and then I input these numbers as strings, right? And then I just run all these tests. And then I'll just go compile. And then when it's done, I run it. You can see it just spits out these numbers. Because in normal coding, we are going to treat these numbers as numbers like int, float, long, doubles, all that stuff. But they have a range. if you go outside that range, things will become wonky. And string math is here in order to fix that wonkiness. So that's the thing that we have. Another good example, just to show what is string math all about, is I can actually do a for loop just to show you. So over here, let's do a for loop. Let's do int starting from 0, int less than, let's say maybe 32 whatsoever, I++. Okay, let's do what should we do? Okay, for an example, I'm just going to say int. I'm going to call this thing box int. Let's say starting from 1, okay, and then long box long, also starting from 1, and then now it's a string. I call this thing box string, and because it's a string, I will give it 1 over here. Okay, now every time, what we're going to do is to say box int will be box int multiplied by I. The same goes for box long as well. So box long multiplied by I, and then box string. Over here we will be using string math. So let's go with small wall, and then we go multiplication, and then over here the string will be himself, and then also string no int to string, let's go to string this thing. Okay, so we have that, and then let's see what will we get. First we will see out box int, and then we will output what is the result. We have box long over here, right? And then we have finally box string, which is actually now using string math to do it. Box int long string. Yep, there we go. Now, so basically this is actually factorial to some extent. So I'm gonna just hit save, and then I'm gonna just let it run and then just show you what string math is all about. So over here I'm gonna just click clear, compile, and then run it. Oh wait, stupid me, I let I start from 0. There we go, of course it won't work. There we go. Boop. So, now as you can see, basically what this does is it will give us 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5 multiplied by 6 and so on until it multiply by 31, right? Okay, so now you can see, okay, that's a really huge number. Let's take a look how we are doing. So over here you can see that, okay, first off, both int and long are pretty fine. We have still 1, 2, 6, 24, 120, 720, 50, 40, 403, 20, and so on until at this point, see, there we go. Like, see, look at this. Right, look at this. At this point over here, box in goes from a positive number to a negative number. It breaks. It gets wonky, and there is actually a reason why it becomes negative. I will come back to that. And over here, box long, because box long has like a way bigger size than int, so it is still fine. And string math is just like chillin' over here. And you can see box in has already like well, box in is suffering from this, whatever. Box long has, it's over there, but after a few, okay, just look at box in. It's like it's doing wonky stuff already. Like, it's all over the place now. It's almost something like when the poop hits the fan, it's all over the place. You can't fix it. But when you look at box long, the moment when it goes overloaded, it also goes wonky and crazy as well, and everything went everywhere. And it's also the same thing happened to int. For box long over here, it's just a few iterations, and then guess what? Poop hits the fan, and then everything's everywhere. You go from neck, pause, pause, neck, pause. Like, it's just flipping back and forward. But box string over here, it's just doing fine. It's just doing fine. Like, look at this. It's not negative, and it's growing really quickly, but with still good precision. So this is what string math is built for, in order to deal with really big and wonky numbers. Okay? Like, and I would say this is a really good tool when it comes to cryptography. Why? Because in cryptography, we rely on really huge, big, wonky numbers. Like, you take a number, raise it to something like a 300, well, like, you take a number and then you raise it to the 300th power. If you're just simply just using int or long, you go wonky. But string math over here, I hope string math is able to do that. It's just I haven't implemented that yet. So yeah. Big black pencils. Huh? You might need to explain that to me. That is a reference I do not understand. But yeah, we have that. So this is actually what string math is meant for. No, can't. What? Huh. Okay. Anyway, let's get back to division. Oh yeah, we just done. Oh, okay. Now I'm just going to like whoop, comment this whole thing out. yeah, as you can see, there are a lot of commented code, but whatever. Now we're just gonna test division, and then what was the number again? 13485. Okay, so we just do small wall. Division 13485 by 7. Let's see, what will it give us? It could be wrong, it could be right, or it can get stuck in a while loop. Yeah. Search it on your other monitor. Let me do a quick research. What do we have? Boop, boop, boop. Alright, let's see, what do we have? Let's see what does this thing means. Huh. Well, so far, well, some of the pencils do looks good. Yeah, not bad. Some of them have a low price. $2.99 on Target, $54.46 on Amazon, $12.95 from Walmart. Oh boy, that's a big one. What else? Yeah, so far I don't see anything wrong with black pencils with that. Yeah, minimalistic. Not exactly a problem. Doesn't mean anything. Well, time to go into the darker parts. Let's see. Oh, it's a meme for a thing down there. How is... Huh? Okay, let me check the origin of this thing. Oh, there we go. Huh. How does this thing as with that? Like, I'm unable to like search it. Like everything, all I see is just like Google trying to explain what black pencils are, and then now it starts to try to explain what's the difference between B and H. Like, B is actually black or soft, and then H is actually hard. So, you know, sometimes you have like 2B, 4B, 6B or something, and then sometimes you have 1H, 2H, 3H or something, all for different shades. So yeah. Okay, but well, I do not understand why this is there, but okay. Anyway, precision 4. Let's see what we will have. Let's compile it. Alright, moment of truth. Let's see if our division works. Is that correct? 1926 26428. Huh. Decimal is a little bit off. Let's see. 6. Okay. decimal is off by 1 place. So let's see. So it's over here though. Alright, okay. If plate AR dot length is bigger than 0, then it gets stripped. Or otherwise, if it really is 0. Okay, let me check if number strip has a safety feature. So where is it? Up there we go. If length is bigger than 1, okay. If length is exactly 1, then just return an empty string. Okay, yeah, good. So that's what we have. Watch the vid, it's safe, just a song. I would say maybe not exactly now, but I'll watch it later. Let's see. Borrow from the next digit. It's 1 minute 39. Fine, I'll take a look at it on my other monitor. Let's see. What do we have? Let's see. Okay, let's see. What do we have?
Exactly. Those IEEE bastards.
By the way, this thing looks like a music. Oh, wait. Huh. Okay. Let me have a listen to this. Okay, I did listen it to a little bit, but okay. Well, just in case different people have like different taste or preferences or whatsoever. But yeah, me personally, not exactly a fan of like trap or slow rap in this case. So yeah, but if you like it, yeah, no problem. Oh, yeah. Makes sense though. Also, let's see. 45. So let me I'm gonna go take a nap. Alright. Well, see you afterwards. Yeah. See you afterwards. Rest well. Yeah. Let's see. It's the only thing is that it's 1 digit too early. So I would say okay, over here I would just say if is debug, meaning it's debug time. So over here I will just say cout plate al listing. There we go. Over here I'll just say plate A and then plate AL and then put a pipe in between. There we go. Plate AR. There we go. And then plate B. There we go. And then let's take a look. Counter, or just say count. Use me. There we go. And then we will see what is plate R. So there we go, plate R. Over here, I'll just post it. There we go. There we go. There we go. And then go. Okay. That should look good. Alright, hit save. and then we'll just do a over here. I will just do let's see, huh? 1, 2, 3, 4. Hey, there we go. Compile. All right, let's see, what do we have? Whoop. Okay. Oh yeah, I forgot. We got to like switch on debug mode. So let me do that. There we go. So there we go. Click save. Over here. Let's go. So now we have that. Huh. Oh boy. Clean 0. Maybe let's not look at clean 0 first. So what I'm gonna do at clean 0 is I'm going to say cheat a little bit. So just to say, is debug is false, but when it's done, we turn it back on. So is debug true? So yeah, we'll use that to do a little cheat. Whoop. There we go. Let's clear the screen and then run it. So let's take a look. So our iteration looks, oh lord. Alright, so we have this. Alright, cool. Over here. Okay. So let's. Okay. Just like copy and paste. Small iteration. Just copy that. Paste it. Put it over here. Put it over here. This one over here. And yeah, there we go. So we'll just come back over here. Let's do a clear. Let's do a recompile. And then we'll just run it again. Whoop. So, let's take a look. So we start from here. We pull in the first thing. I thought every time we pull it, we're going to export it. Pull it. Oh, there we go. Okay, we're done with that. Pull it over here. Okay, let's add more descriptions to it. 1, 2, 3, 4. 1, 2, 3, 4. Oh, huh? What? This is so. This is so weird. Never seen this happen before. Huh. Never seen that happen before. Interesting. Yep, there we go. There we have that. Oh boy. Oh, come on. Let's see. There we go. Okay. Now I'm going to say arith iteration start. Just in case, over here I'm going to say okay, over here, boop, this thing. Division start. Yep, there we go. So we have that. Arith iteration start. So this one over here is. Oh, okay. Plate AL and plate B subtraction. Over here it just says that pull the leftmost digits. Pulled from AR. Oh, okay. go. Okay. Pulled from AR. To AL. Okay, so we have that. Now over here, I'm just gonna this one over here. Complete are only if player do not have a decimal point. So decimal point added. L edit 0. Export counter to R. There we go. There we go. Done. There we go. A plate B. C. And then we'll just like copy this whole thing. There we go. Division. And so we have that. There we go, and then we just run it. Whoop. There we go. So let's see. There we go. So pull export. Okay. Arif iteration start. Oh, okay. Pulled from this export. Yeah, which happened in the demonstration as well. We also export 2 zeros at the beginning. Arif iteration start now. Okay. Oh, okay. 485 64 85. Oh, okay. We'll counter to that. Every time we pull it, we export. Okay. Now start again. Now this thing can be crunched down multiple times. Counter start, counter start, counter start, counter start, counter start, counter start, counter, then counter start, counter start. We which is 8. Okay. Counter start. Now we ended up with this. So we pull it. We export. Okay. Do this again. So we ended up with that. 45. Pull from this to that. Export. Arif iteration. Do it again. So in the end, we have this. So in this case, we need to export first and then decimal point. Huh. So interesting. Yeah. Okay. So export it first. Over here we will say no. Export C to R. And then yeah. And then if AR has anything to get pulled. No. Let's hit save. And then let's see what our answer will be this time. There we go. Now that looks way more correct than what we had before. So so we just come over here and then just, oh wait, before that I'm coming up here and then I'm just gonna say debug over here, let's just go with this. There we go. And then we're just gonna hit save. And then hit save. And then just gonna go with a test. But over here, it's just going to say false. Let's see. I'm going to have some whatever weird one divided by whatever the okay. So I'm just going to take 4 3 60 313 divided by 17. And at this point, I've just punched on my calculator, and it should be a perfect number. Did I forgot to save it or something? Let me compile it. All right. Boop. It got stuck into a infinite loop. But why? Alright, let's see. Alright, let's see, what do we have? Just got stuck in between cleaning zeros. Error? Oh, that does not look good. Oh. So, it has problem with cleaning zeros. So let me see. What's the problem with this one now? 4360313. Let's do a clear. Let's do a recompile. And then let's do a run. No problem. Hmm. Okay, fine. I guess I have to do the cheat again. Just this one over here. So I'm gonna say is debug is false over here. Is debug true? Hit save. So at this point we say that, but over here it says this. Compile, and then the moment when it starts running, I'm just gonna press Control C just to like halt it. There we go. Does it even go up? Oh no. Oh wow, guess we have to step through. Guess we have to step through it. Excuse me. Alright. In this case, I'm going to set string. Okay. String temp box is empty. I'm going to say get line cin into temp box, and then when we're done we will continue or whatsoever. Alright, let's see, what do we have? Clear, compile, just run. Huh. So this means that there is another. Oh wait, wrong one. It should be somewhere else. Yep, there we go. Whoop. There we go. Clear it. Run it. So every time when I press enter, it just runs one iteration. Iteration pulled. Okay. Iteration pulled again. Export. Okay. Now I can actually start minus stuff. So yeah. Okay. So in the end, at least we have 2617. Okay. And then, yep, it's still doable. Whoop. 2617. And then, whatever. Some we have 9. Okay. Iteration start, so we have that. This goes there. So I'm expecting 2.5. Oh wait. Oh, is it? Content plus plus, iteration start. Throw it over there. And then export that to that. Huh. Wait. Okay. I'm expecting to see a 6. And then pulled another 3. 6 got output right there. Expect a 4. Okay, yeah. So 4 get output. Okay. Next thing I'm going to expect is a 8. Here we go. 8 got output. Yep. Oh! What does it say here? Arif start. Huh. But just in case, what is this part doing over here? Like, okay. Over here, because we are using subtraction, I'm going to say this. So over here, we can say subtraction start. And then we can just actually copy and paste and then say when subtraction ends. Alright, let's see. Cleaned zeros. And over here we're just gonna say given decimal dots. Padded number with shorter frac length. Oh. There we go. There we go. And then we just go. Whoop. Iteration start. And there we go. Okay. Oh boy. because things went wrong over here. Go, and then so over here we're just gonna do a quick view iterations. Over here I'm going to expect to see 151. Okay, good. Okay, good. Now over here I'm expecting it to like keep on going, but over here it breaks. Clean zeros, give decimal points, padded number with shorter frag length. iteration start, iteration end. Ooh. Subtraction start. Wait a second. So if over here we have okay, subtraction out, subtraction end. We do not have subtraction end. How can something, how can the subtraction start but did not end it? Well, if this is a debug, then it says iteration start. Okay, subtraction. Then it starts over here. Subtraction. Pattern with number with frac length. Over here it says iteration start, and then whatever it goes through, it does not go through here. Also, if both of them did end up with like these dots. Oh. Over here, we'll say flip mechanism. point, we'll just print these two. There we go. Copy this thing. Now once everything is done, we have that. Otherwise, we're dealing with the decimal point. Else, normal calculation. There we go. And still, I do not expect this to like exactly work. Well, let's see where does this thing goes. So normal calculation. Last character. Get last character to character set. Arif A. Well, it becomes not intelligence now. See out RFB. spell B. It might be this again, but what it is this time? What? Was not declared? How come? It was right here. Oh, big A, big B. Okay. Clear, and then just run, and then let's see. Oh, there we go. Arif A. Huh. Arif B. So, huh. Let's take a look at what's in plate A and plate B. Okay. Let's see, what do we have? Let's hit clear. And just run it. Hoop. Alright, let's see. Plate A is 1, plate B is 1. How come Arif A is -1? Number get last character. But why does it not get it? see. Plate B dot length. So at this point, I just want to see what are the length of each string. So go, save it, compile it. And then we're just gonna run it. Huh. So turns out, for some weird reason, plate A has a hidden character. So let's do this. 4 dot something. Oh lord, IntelliSense is not IntelliSense anymore. Cout. What about force print string ASCII? Where is it? Force print file ASCII vector user strings. Nah. Okay, so it's a string over here. Detect. Well, let's see. Print ASCII. Okay, so just string detect print ASCII plate A. Okay. Print ASCII void snap. So this means that we have to say this thing cut paste cut paste, and then this one over here will be plate A dot length, and then this one over here will be plate B dot length. Okay, so now let's just compile it again. And then we're just gonna say clear, and then we're just gonna run it. And then let's see what does it says. There we go. Huh. It has a null string attached to the end. But for what reason? It has a null string. Yuck. So what does... Huh. Wait a second. Number strip. What does number strip really does? After decimal point, after decimal point, we have this. Okay. Why do we have a null character right there? Iteration and iteration start normal calculation. Arith iteration. Let's say it's arith iteration. Oh, okay. But here's the weird stuff. How come it goes from this to this? Oh, wait. If we borrow from the next iteration. Oh. So, huh. Do we need to borrow from the next iteration? If the answer is yes, because now we're trying to borrow from a 0. And this is actually the flip mechanism. Oh boy. Okay. Ooh. We might need to introduce a new mechanism character called the full digit. So this means that when we want to borrow borrow huh let's take this current example, like, because right now 102 minus 7 So what we can do is oh boy. How can we borrow iteratively? Okay, let's make a new function. Okay, let's use. Alright, bug, let's say unable to count 102 minus 17. 7 is bigger than 2, need to borrow, but next digit is 0. String will be corrupted, and when 0 minus 1, we will get the null character. So let's deal with this for now. However, let's make something. In this case, let's call this borrow flip. And then I'm gonna say borrow position. So so basically, let's see. Let's see. Let's take a look at the subtraction part. Let's see how it's done. So I'm gonna just pull this thing over here and then just split it. Where's the flip mechanism? Oh, there we go. Okay, so I'm just going to paste that over here, meaning this is meant for that. Now, Alright, let's see. Let's do pointer. Although it's not exactly like pointer, but in this case it's just a name. So let's do plate A dot length -1. So pointer over here will be pointing at the last digit. So you're just gonna say in A, right? Over here I'm going to say string plate A is in A. Flip mechanism. I'm just going to like copy and paste the whole thing. So copy, paste it right here. So over here, uh-oh. There we go. Over here, there we go. So over here we have this thing where point A at this is that, or if that is this. Let's say if position, okay, technically speaking, this will be in position. There we go. Yep. Now, if this thing over here is a 0 or a dot, then do something with it. If it's a 0 character, then full blast it, and then pointer minus minus, gone to the left, and keep on doing that. If you hit a let's see. We have that. Where is it? Pointer this. Okay, so if that is a 0, then that thing will become this, and then move to the left. Otherwise, if this thing is the dot, keep on moving until when you hit the point that it is not a character 0 or it is not a character dot, then at that point you will then decrease its value. So there we have that. And then when you are done, there we go. So hit save. So this is a new stuff. So let's test this thing out. So in this case, we can just do string math over, and then we do number borrow flip. In this case, let's just go with this, and then the position, let's say 0, 1, 2, 3, 4, 5. Let's just say that. So let's hit save. So let's hit clear. So if we were to just simply compile that, and then just run it. Yep, we got that right. If we were to go to position for, you know what? Let's go with whoop, whoop, whoop. 4, 3, 2, 1. What if we even go with 0? Let's see what happens. It might gone wrong or whatsoever. There we go. 4, 5, 6. In this case, we are flipping this one. We're now flipping this one. Like, this is like some really unexpected results. But yeah, we just need to like make sure that the one that we're flipping is a 0. So get back over here. And then over here we can say if in position is too big. Let's say plate a dot length, like if that is too big, we can just say oh boy, intelligence is not kicking in. Hey, see out. What? Console quick? Is it? We can say error, and then we will say position is out of range, will not flip. There we go. And at this point, just simply return the original string. Or otherwise, no problem. Or let's just say if this thing is this thing, or I should say, if not, then put it over here. You can also say given position is not a 0 will not work. So we do the same thing again. Oh, in A? Oh, okay. Okay. Looks pretty good. There we go. Compile. So, whoop, whoop, whoop. Yep. Flipping that one, flipping that one, flipping that one. The moment when you start to try to flip a 6, it will not be happy with that. And then yeah. So the moment when we come down over here, flip mechanism, zit. Oh, over here we have that. So over here we can just do plate A is number borrow flip plate A and then the position of it. So in this case it would be the last one. There we go. So this counts for this, and then yep, we have that. If the last character is a dot, then remove the dot. Now, normal calculation. Get last character. So, okay. Now, do we need to borrow? If so, so so the new idea will become, alright fine, I'm going to let you do that. Look, now I'm going to allow you to borrow from some other stuff. Like for example, other than 0, yeah, I'm gonna let you do that. So this means that we need more precautions in this case. So, position out of range. Of course, it will not work if this thing is not a 0. Okay. Then it should be actually pretty easy though. Because what we can just do is just this. Like, that thing will just become... Okay, take that thing, interpret as a character. Give me the position. -1, put it back to the character. And then... yeah. Return in A. I would say... place A. So... plate A is in A. And then now... plate A... yeah. So let me hit save. So let me compile that. Run it. So over here, we borrow it from here, 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 borrow it from here. So all of that looks pretty good to me. So that looks good. Hey. So let's look at where is it? And actually, this is the same as whatever we have over here. So plate B, and then plate B, and then from plate B dot length -1 whatsoever, meaning it's the last one. So whoop. Okay. Else, if the last character is a dot or whatsoever, decimal point removal. Yep. Otherwise, normal calculation, get the arithmetic value, figure it out if we need to borrow. If we really need to borrow. Oh wait, I haven't tested for decimal points yet. Okay.
Let's see what we have.
So now let me just copy this whole thing, paste it, and then just go and just whoop, whoop, and there we go. Now at this point I can just go this, and then expect it to like work. If I'm pointing at a decimal point, will it work? Let's see. if this thing, however, what we can say is for is it a no vector find object position. What we need is the character set, and then our target, it would be plate A dot at pointer, and then starting from the left. Now if this thing appears not to be -1, then it means it has a numerical value and can be dealt with it. And then now if somehow this thing is character dot, then we messed up. So I'm just gonna say position is decimal point will not flip. There we go. So we hit save. We have this. Zero, 1, 2, 3, 4, 5, 6, 7, 8. So 8, 7, 6, 5, 4, 3, 2, 1, and then Control C, and then Control V over here for reference. Let's go with 9, and then let's go with 0. Some of them will just go out of range and it will not work or whatsoever. We'll see about that. Cool. Alright, there we go. So over here, position is out of range. Will not flip. And then this one, oh yeah, it just gives us what it was. Flips, flips, flips. Position is a decimal point, will not flip, so it just gives us that. Flip, 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 yep, good. Alright, so now it works with decimal points, sort of. So coming over here, okay, cool. So now we have that. Whoop. Alright, what do we have here? Okay. Frag length. Iteration start. Okay, flip mechanism. So we have that. Okay. So, if the character on the left is a decimal point, I can say number borrow flip plate A position something, so plate A dot length minus, like, okay, if this thing is a dot, then we'll just do it -3. And this one over here takes care when it is 0. This one, however, does not. So, whoop, that thing's gone. This thing, it's the same. Oop. This one is 2. So that one's gone. And then all the maths and all that stuff. So let's hit save. So let's go. Before we test the stuff, let's just make sure that subtraction now works. So the subtraction, we were testing 102 and 17. So now hit save. Now compile. And then run it. 95, is that correct? Let's go with 102 minus 17. That is 85, so it's wrong. Alright, let's see. So, oh, okay, so we have this 102. Alright, got it, got it, got it. 102 and 17. Okay, 2 and 17. Arith iteration 10, 17. Arith A is 12. Okay. How did that Hmm. Oh wait, I forget. Plate A is then that, or otherwise, plate A is then that. There we go. That should be it. So, recompile. Oh, I forgot to save that. Okay. Let me recompile again. And then we will run it. And hopefully get 85 out of it. Oh yes! There we go. So now it finally borrows properly. So now, so this means subtraction is sort of fixed. So, now I'm going to try a new number. So, just to come back over here. Oh, cool, we still have that. Good. So, let me test that. So, 4360313 divided by 17. Alright, I have my answer now. So let's see. I'm gonna clear this thing. I'm going to hit save. I'm going to like compile. Run it. And every time I'm just gonna press enter a few times just to hopefully get the correct answer. Okay, we first get our 2, which is good. Alright, we got our 5, good. We get our 6, good. Looking forward to get a 4. And then an 8. Okay, now at this point over here, we were stuck at 102 minus 17. Hopefully this time we are able to get a 9 out of it. There we go. Decimal point. Ooh, now the new problem becomes when plate A is like completely 0, what do we do? Because... oh! There we go. Perfect. Perfect. Division now finally works. Oh, Lord. Division now finally works. Alright, I'm going to test myself with some weird prime numbers. Let's go 1009, that is one of them, multiply by 257. So that's actually a pretty good prime number, and you usually use this in cryptography. However, practically not exactly, but yeah, whatever. So now division is finally good with iterative jumps. Let's see where it is. Ah, there it is. So we don't have that. Let's hit save. Let's go to test. And then let's go C out, small wall, multiplication let's go with 1009 and 257, and let's save this as a string. I call this thing part 1. Right, and then what I can do is part 2. I can say small dot multiplication, and then I can just take what is in part 1. Oh wait, no, not multiplication, in this case division. Division. So far we haven't dealt with decimal points yet in division, but we'll take care of it. Let's divide that by 257, and then hopefully we will get the right answer. So part 1, let's print that thing out, and then see out again. Part 2, let's print that thing out. Okay, let's hit clear. There we go. Oh. Oh. I always forgot that we need some precision number. There we go. Compile. And let's just say, just run. There we go. So over here, we got our final result. And on my calculator, yes, we do have 259303 as our answer. And at the beginning, we have 1009 over here. Multiplied by 257, we get something. And then we take this something divided by 257 with 4 precision. And then we get our answer back, which is 1009. So that's actually pretty good. Another thing that we can do is once we go here, our division, what we can do is let's clean our numbers. So number, clear zeros. So hit save, recompile. Clear zero. Okay, then it should be clean zeros. Oh yeah. Well, the compiler is clever enough in order to catch that. And if we just run it, we have our sweet good old 509-313-1009 right there. So there we have it. Oh, finally. Okay, so now at least we have multiplication and division, and then yeah, soon afterwards we can have division safe, just to deal with positive and negative numbers. And then you know, originally we were aiming for modulation, but I would say this is really a good